We'll play tomorrow. And we'll figure it out from there. So the Vulcan Cert is... Tori Bruno says that it's supposed to be live now, but it's not. The stream says 6:45. I bought this game when it was on sale recently. I'm a bit apprehensive about the steep learning curve. Yeah, learning it's tough. I'll play Stellaris tomorrow, Tomast. I'll figure out what I'm doing a little bit better later. Or we could go back to playing Hearts. I want to try Stellaris more. Hearts is fun, and I enjoy it, but yeah, we'll see what's up with Hearts. Do you have all the DLCs yet? Yep. Yeah, chat bought them. Well, I bought them, and then chat reimbursed me, I guess, if you want to call it that. Compared to Hearts of Iron 4, I'd say Stellaris is upfront more complex, but it has much simpler mechanics. Yeah. I think you want to wait for the next Hearts of Iron DLC. It's the finish. Yeah, maybe. Apparently they're doing a recycle test and then the flight readiness firing. That's John Krause saying no. It's a sarcastic remark, dude. Yeah, Singularity. I love Hearts. Hearts is a guilty pleasure. Big guilty pleasure for you, boy. Are there any small wrenchings you could do on the truck? Like a quick 15-minute job. But they're doing another green run. Galactic, the stuff that I have left to do is something that's not going to take 15 minutes. I have to grease all the fittings on the truck, the Zerk fittings, but they're all words. The grease gun, I haven't loaded the grease in the grease gun and everything, and I don't feel like getting dirty right now, especially if I'm going to go back to the computer. Everything else is just small wiring things, like wiring up the radio, and then the license plate lights, which is drilling some holes. I got to drill some holes in the bumper, and I got to kind of shore up everything on the back end of the truck. Like the bumper, for whatever reason, I noticed is mounted weird, and I don't know what I was doing when I mounted it. I got to fix that, and yeah, then we got to drill some holes for the plate. Just a heads up, remember the SDA launch from the tracking layer from Vandenberg that had some SpaceX-made hypersonic tracking sats? A company called York Space tried to do a presentation for their investors and ended up leaking intellectual property and pics of their... Lovely. KSP is more guilty than Hearts. How about a musical interlude? EJ shreds out a tune. Nah, I'm alright. Here, let's see what
Makes
NSF
perfect
is up
sense.
to.
And since there are some people that haven't been with us for this stream, as we continue to wait for the actual firing of those BE4 engines, there is another fire that you may occasionally see on screen. And so for those of you wondering what those flames are just above the trees to the left from this particular view, that is getting rid of all of the excess methane. There it is. You can see it in that view just to your left. That is a diverter that will take all of the extra methane away from the rocket and then burn it off so that it burns cleanly away into the atmosphere instead of building up and burning inside of maybe a closed space, equaling to a very, very bad day. Because this is, at least the first stage, is methalox. So it is methane, or as ULA refers to there, as liquid natural gas, and oxygen to power it. And there is actually, I believe it's hydrogen as well on that Centaur stage too. So technically there's two burn-offs going on, but the most visible being the methane.
Yeah. If you're having trouble locating what we're talking about, it's just above the trees. See that like bump of trees on the very left-hand side of the screen? Every now and then you'll see like a little, there you go, a little wisp of flame that comes up above it. It's like it was listening to me. And that's what we're talking about. Okay, is that venting? That's venting on the right-hand side. I don't think that's a flame on the right-hand side.
That's the hydrogen.
I think that's a flare.
Do you think that is a flare?
That is a flare stack,
think
it looks
so.
like, to
It's
the
the
right of the
hydrogen
towers.
flare.
Yeah,
We
the two
should expect
sticks.
venting though. I'm not sure if now or like later once they do the static fire. That ULA, that ULA sphere that you see white behind one of the towers, I think that one is one of the.
Okay, so over here behind my head, that's the hydrogen purge line. And then over there is the methane or LNG purge line. What are these for? So Vulcan has a fully cryogenic first and second stage. But the second stage is using hydrogen. The first stage uses LNG, liquid natural gas. So that's like methane, butane, and I tell you what, boy, it's a little bit of propane. LNG is just butane, propane, and methane mixed in the right quantity, in different quantities. It depends on what you're doing, right? I mean, I'm sure the LNG that's on Vulcan is different to the LNG that was on Terran 1, for instance, right? Ooh, rain. Is it raining? Yeah, it's raining. So, because of this, you need two different fueling systems, right? You need a fueling system for methane and you need a fueling system for hydrogen. Now, when you top these propellants off, they like to turn to gas, especially hydrogen. And when they turn to gas, well, if you don't give that gas a place to go, it's going to find and ignite. It's going to find a place for you to ignite and probably blow your rocket up. So these purge flames are there to basically cycle the gaseous, the boiled off gaseous propellants away from the rocket and make sure that the thing is topped off with the right amounts of LNG and hydrogen. The thing about LNG and hydrogen is that they're being stored as liquids inside of the rocket. Being stored as liquids, when, hydrogen usually is gas down here, so is oxygen for what it's worth. So is LNG, liquid natural gas is kind of in the name. When they're stored as liquids, they're really, really, really freaking cold and in a really, well, not high pressure, but they're at a higher pressure than ambient, right? Than what you're breathing right now. When that happens, geez, that's a Florida rainstorm. When that happens, the propellants like to boil. So when they boil, you get gaseous methane in here and gaseous hydrogen. Two things that you do not want near the rocket at all, ever. That's why those purge flames are there, to circulate the gaseous boiled off propellants away from the vehicle. Why can't they just vent it into the air? Venting LNG into the air makes Captain Planet want to come and kick you in the scrotum. Yeah, environmental, you don't vent methane. Bad idea. Same with hydrogen. That, and I wouldn't want to vent liquid methane and liquid hydrogen right next to, or gaseous methane and gaseous hydrogen right next to your gaseous oxygen vent, which is the one that's on the rocket. You don't want to vent all three of those next to each other. Explosions. The thing will Hindenburg itself. Wow. Okay.
Not buffering or anything. That is not YouTube being YouTube. That is
a
Mother Nature
rainstorm.
being Mother Nature, Florida.
That's all the all the cameras we have at Cape Canaveral right now. There you go. You can see the parking lot there in the foreground, but you could barely see. I guess the VAB would be off to the left of this shot.
And that would be invisible too, I believe.
Yeah,
Do we
That's
have
the
radar
turning
maybe
basin.
that we could pull up at least, so we could see how bad of a storm
No
this
one's
is?
gonna get mad,
the Intercept
Owens,
Weather
if you
Center is
vent
still a-
gaseous
still a-
oxygen into the atmosphere.
Beautiful.
I don't know if we're still getting that. There we go. Let me hop over to the latest frame. There's where we are right now, and you can see here.
So the
in
pad
middle
is right
wall,
here.
That is the press site right there, and this big storm track moving along this line here. So that red is the reason we can't see the rocket, and it's going to continue right over the top of 41. Slick 41's almost due east here, and so
on.
that will take a little
Am I the
time
only
to
one not-
pass.
Am I the
go
only
ahead.
one not seeing the dostration?
Well, we saw it for a second, and then it went away, I guess, right? Did we actually see that? I thought we saw it. Anyways,
Anyway.
I was acting like we would see it.
Yeah, I thought we did, unless I just looked incorrectly in our preview back here. But yeah, no DOS art showed up.
Refresh. Thank you. There we go.
There we go.
All right. Sometimes the way we've got it set up requires a little kick to keep it going. So what I was saying before I was so rudely interrupted by Indy Bridge, this is the big cell that we're looking at. The red dot right there in the cell is actually the camera location, and then Slick 41 is over here to the east. You can see the track of that is sort of going in this direction. So not a lot behind it over here, and hopefully this passes and doesn't affect the test, and we get a clear shot back in that
The
direction.
camera's
We're back
right
over
there, the
towards
pad
Slick
is right
41.
there.
Over at the Space Force Station shortly. Back to you. I just like saying that. I don't know. It's like signing off the weather update or what.
Back to you, Ollie. Why does it feel like if this was my company, I wouldn't want to test my rocket in this weather?
Wait, we do?
That's probably why they moved it back a little bit, Alleviate.
Discovery,
Sounds like
go
we
and
know.
throttle up.
Tico!
But yeah, so the weather is definitely something that we will try to keep an eye on if we can actually see anything besides the rain itself. And I see all of the Vandenberg jokes going on in chat as well.
Nice. Yeah,
This
there's
is
a
rain,
VAB.
not fog.
Look at that.
There's a VAB.
Yeah, because then it will be a Slick 3. So this is Slick 41 for Vulcan.
Right. I mean, if,
Maybe the other will probably do it at one point. We'll see.
Right, this isn't USSF 44.
This launch or this weather happens in Florida every afternoon, guys. It's a little bit late this time around. Usually it's like 3:30, 4:30, but basically, because Florida's really close to sea level, it's very damp, right? It's very swampy. When the sun comes up every day, it starts heating up all that moisture, all the fresh water that's in Florida, right? And that all evaporates, and all that condensation goes up into the clouds. And then eventually, like when you get to the late afternoon, the clouds literally just can't hold any more condensation, and it will just, it'll do that. It'll just piss down rain for about 30 minutes. And then by the time it's done, the sun's low enough on the horizon where all the moisture goes down, back into the ground, only to be repeated literally the next day, every day, 3:30, 4 o'clock, without question. And the crazy thing is that depending on where the clouds are, it's kind of sporadic. It could be a perfectly sunny day and then just rain cloud. Like, it'll go from super sunny, like at 3 o'clock in the afternoon, super sunny, not a cloud in the sky, to like 4:30, literally this. It'll just, all of that eventually condenses and then just boom, right there. So yeah, this is a little bit late. 6:30 is usually a little late in the day. But yeah, it is, there's definitely a lot of water.
Or, you know, whatever. So
Super sunny retro precipitation, yes.
Continue to wait that I really wanted to hit about reusability. 'cause
It'll
obviously
clear
that's
itself up
something
here in a
that
moment.
We've seen a lot of in the recent years. We'll start with the first stage. Alan asking, is the booster reusable? So what's the plan for the reuse?
Fast forwarding.
Onward.
Yeah, so
They expect the weather to become better. Tomas,
It's
watch. The skies will
pretty
clear
much
up. Give it 15
not
minutes.
right away. It's not gonna be.
I mean, look at how clear the sky is compared to like here.
but
I'll show
later
you.
down the line, they're gonna
Let's go
try
back
cover
to
it.
here
But yes, so the weather
Go
is,
there. and then go to there. See what I mean? Look at the difference. Once again, back and to the left. Back and to the left. See? Clouds are already going away. Crazy, right? Help. Departure in port for the Starlink 511 mission. Tug is Crosby skipper. ASDS has just read the instructions. Bob to follow later for fairing recovery. Cool.
The whole thing.
Discovery, go at throttle up.
Mid-air.
Jeffrey,
basically.
16-month resub. Thank you.
But,
Wait, what do you mean the whole thing? The whole thing?
The whole thing, the whole
the parachute
engine-
and the engines.
exactly the engine and the heat shield and everything, all of that. Not
Nice,
the booster,
W.
not the rocket.
Since when
not
can
the
weathermen
engines.
predict the
And so
predict the
that
weather,
was
let alone the
original plan,
future?
But now what they're doing is just splashdown and save the helicopter. So they've gone just like rocket.
Does the condensation from moving weather patterns affect launches? Rain
Discovery,
doesn't
go
necessarily.
at throttle
Oh, Predominant gifted out 10 subs. Thank you very much. Rain doesn't necessarily mean you're not gonna launch, dude. To be honest with you, thanks for the 10 subs, man. I really appreciate it. So what you really got to look out for, like their three big ones are cumulus clouds. Sporadic rain like this doesn't necessarily scrub a launch. Literally just wait until there's no rain clouds over you and then go. But cumulus clouds, so too many clouds. Like if you have clouds low between like 2,500 to 5,000, right? And then you have clouds from like 5,000 to 10,000 and clouds from like 10,000 to 18,000. Cumulus cloud rule. There's too many clouds. It's not that it wouldn't be able to make it through. It's not that it wouldn't be able to launch or anything. But you're rolling the dice for flying through all those clouds, just like you are with a plane. You don't want anything weird to happen. And that brings me into the next rule. Anvil cloud rule. So the anvil cloud rule is basically don't launch in a thunderstorm. Don't launch in a thunderstorm. If it looks like a thunderstorm, it'll make a cloud that kind of looks like an anvil, right? Because with the thunderstorm, you get a lot of heating, I guess, heat changes. So the cloud will end up looking like an anvil. If you see the anvil cloud, yeah, ooh, a bulk carrier, very nice. If you see an anvil cloud, don't launch, because you could get struck by lightning. Now, just because there's thunderstorms in the area doesn't necessarily mean, right? Just because there's thunderstorms in the area, look at the clouds clearing out, by the way. Doesn't necessarily mean that there isn't charged electricity in the clouds. You could have clouds that don't look like anvil clouds that still will carry a charge in them. And that's the third most violated rule that they have in down at the Cape. Actually, there's four. The fourth one is wind. That's pretty straightforward stuff. But that third one is called the surface electric field rule. So surface electric field, what does that mean? Don't launch the rocket in a scenario where it literally will become the lightning rod. Don't launch the rocket on a trajectory where it gives electricity the path of least resistance. They tried that once in the 60s. It didn't work. Well, it kind of worked. Basically, on Apollo 12, they launched it, and lightning struck it, and it arced down the plume to the tower and grounded out the onboard flight computers. It basically fried the signal condition electronics. So basically the antennas, the systems that were powering the antennas, signal condition electronics. All right. It destroyed that. Yeah. They almost lost Apollo 12 on the way up because it got struck by lightning twice. So fortunately there was a flight controller named John Aaron that, knew this pattern of behavior from testing for some random reason, and he said, switch your signal condition electronics to your auxiliary power source, ECOM, try SCE to aux. And they did, and Apollo 12 went off without a hitch after that. But yeah, That's where they got the surface electric field rule. Don't launch the rocket in a condition where it will become the lightning rod. Do not give electricity that chance, because just because there's not thunderstorms doesn't mean that the clouds aren't charged. Ecom. Try SCE to auxiliary. SCE to aux. The hell is that? Boat. Tugboat. NASA space flight. See, look at the clouds clear out, guys. Sun's coming out. What's ULA? United Launch Alliance. They're a joint venture rocket launch, a commercial launch provider, between Boeing and Lockheed Martin. I wonder what would happen with a rocket made of stainless like Starship. Nothing good, Tomas, if that's what you're asking. Stainless steel is still conductive of electricity. Yeah, not good. Hey, Pasquale, what's going on? Ooh, beach cam. Remember, guys, life's a beach. Dig it. Good enough. What are we watching? This is the ULA flight readiness, Vulcan flight readiness firing. It's the first static fire of a Vulcan booster. That's right, Alpha. Yep, you got it, buddy. Yeah, the fourth rule, guys, is wind. Yeah, but keep in mind, it's not just wind on the ground. It's mostly wind up there. I mean, most rockets can launch in pretty good windage conditions. See, the sun's coming out. Look. This is Florida, dude. It goes... Here, back up. It goes it goes to this. From that in 15 minutes. Yeah, see? Crazy, right?
Hit the elephant in the room.
I was about to ask you to address that. Yes.
Okay.
Yeah, we're gonna
Pat's coming back into view.
Yeah, if we come back, there you go. So, you can see here, there's...
ULA recycling for the FRF after a successful countdown test of the final 7 minutes.
Is that a space elevator on the right-hand side?
Yeah, right. What's that thing with these other, like, arms on the side? Yeah, that's the Starship pad at LC-39A. You can see it from Playa Linda. Yeah. And actually, it's not... So we're seeing there that flare a little bit, like that flare stack.
Yeah, Poison, that's the thing.
It's not the only flare.
People say, oh, you're fine inside of a car because it's got rubber tires. It's an insulator. No. Cars are a Faraday cage. You're not touching any of the metal. Electricity takes the path of least resistance. Electricity flows better through metal than it does through you. So cars end up being a Faraday cage when lightning strikes them. The electricity goes around you and then goes through the ground. Trust me, the rubber on a car's tires are not enough of an insulator to be able to absorb all that energy. No way. No, not a chance. That's why if like a car gets struck by lightning, it usually just melts the tires. Because rubber can only take so much electrical before it basically just melts. Yeah. Like a short circuit or something. Not something you want.
Is Vulcan, which
there we go. Pad's
still
coming clear
venting
again.
Away, or at least frosting away. Not sure if that's an actual vent or just the condensation of the supercooled propellants as they hit the.
Think if you took a sponge and you poured a bucket of water on it. Yeah, the sponge will only absorb a little bit, and then all the water goes everywhere. That's that's a good way of saying that, Pasquale. Yeah, exactly.
Right.
Electricity is quantitative like that. If you flow too much water through too small of a pipe, the pipe bursts. If you flow too much electricity through a wire that's too small, well, that electricity has no place to go. So it will try to go through the air. And then that'll generate a lot, well, not try to go through the air, but it'll basically heat it up. You try to pass too much electricity through too small of a wire, it'll get really, really hot, and then it'll melt, and then it'll try to find a way to go through the air. Hopefully no one's near it. Usually results in catching on fire, though. Hey, Byron. Yeah, it's not the rubber tires. If anybody says, oh, you're finding a car during a thunderstorm because of the rubber tires. Nah. Speaking of fire, what's that to the left? That's the methane, or the gaseous methane purge line, and over here is the gaseous hydrogen purge line. That is the gaseous oxygen vent line right there, the GOX vent. That's the methane, gaseous methane purge line.
Jack Byer, our own Jack Byer, is on the chat, and I'm seeing that he's complaining that people are saying that this is, oh, it's like.
Don't car tires have metal wires in them? The steel-belted radials is the modern tire design, officer. Yeah, there's steel encrusted inside of the rubber to make it stronger. Yep. What are the four surrounding towers? Lightning rods, Den. So lightning doesn't hit the rocket. The lightning tower, the four lightning towers are taller than the rocket that sits on the pad. There's a very good reason for this. Yeah, see? There's the rocket. Is there a reason why the Starship pad doesn't have lightning towers? It's not finished yet, Tomas. Okay, why does 39B only have 3 lightning towers? Asymmetric pad GSE design, Creeper, is the reason. Oh, look, that thing, Windows is being useless again. That's good. Seriously, I go to click on the start menu, and whatever that piece of junk is, oh yeah, that's what I want from my start menu, the screen to go blank. Yeah, that's great. What piece of bloatware you got for us now? Thanks, Bill. Keep up the bad work. I'll show you. Complex 39. The 2 pads of Complex 39 have an asymmetric GSE configuration, believe it or not. So check it out. How are you gonna put 4 towers here? You're gonna put one there. You're gonna put one there. Can't do that. There's something in the way. Can't build it. Something's in the way. There's something over here, and there's also lines over there. That's why there's 3 instead of 4. You can't. It's hard to do 4 because there's condensers right there. It's the whole thing is asymmetric because it has that access ramp on one side, and once again, asymmetric GSE. They have pneumatic systems over here and HVAC systems over here. And then whatever that thing is, I don't know what that is. I don't know what this thing does. It does something, though. Probably electronics or something. Yeah, asymmetric, dude. That's why it has 3. 39A was supposed to look like this, too, but $30 billion. You know what I mean? Electricity is weird? Nah, it's not weird. So that's Slick 41. That's the pad we're working on. Slick 41 does have asymmetric GSE, but they were able to piece the towers in such a way that in a symmetrical configuration. Funny thing is Slick 40 is the same way. 40 has, despite using a different rocket, that's a Falcon 9 pad, right? Towers are in the same spots. Pretty cool, huh?
They have about 240 tons of thrust.
Okay. Question. Did the test fire happen? No, it got delayed because of they were doing a 7-minute dry dress, or not dry dress. They were doing a 7-minute simulated countdown, and then they're recycling for for the flight readiness firing now. So many launch pads. There's like over 40 of them down at the Cape, Byron. I mean, keep in mind, there's not just because we get complex 39, 40, and 41 doesn't mean there's 41 active pads. Some of the pads were demolished and then rebuilt, and when they were demolished, they, like, let's take Complex 17, for instance. Complex 17 was demolished, and Space Launch Complex 17 was built in a different location. So, like, the naming system is kind of all screwed up, but it's all right. Question, and now this is going to sound dumb. Is the airspace over 39A? It is a permanent flight restriction. Alleviate, yes. You don't fly over the pads. No one flies over the pads. Have you been staying hydrated, sir? Yep. You can in Flight Simulator. That's good to know, Gregor. Good to know. How are we looking? Looking all right. ULA should... Okay. Should be getting back to it. I'm currently rifling through these stupid taskbar settings.
On top of the
Any
Delta
desire to go back
Project
to my
second
summer
stage,
car after the
which
wedding?
was like
I don't
bonkers
know,
for
Dead Crew.
Delta V,
No
like
guarantees, buddy.
the impulse, the yeet that it was able to give to the probe, right?
Is that an emergency egress cable from the launch tower? There is an egress cable that goes this way, yes. See it over there? Yep. It's basically a zip line. I'm serious. ULA contracted a zip line manufacturer to do that. That's when Starliner is on the pad. That is used in case they need to egress out and get off of the tower, and say for whatever reason they can't use the elevator or the stairs, they can get out that way.
Or 6 configurations.
Okay, I'm going to switch over from our buddies over at NASA Spaceflight, and we'll get to ULA.
Here at the Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida.
And the audio is just awful.
Twin BE4 engines is scheduled within the window this evening. The team is currently coordinating a new T0. Testing can often be challenging, so the team planned a window of time to work through any necessary issues. This is a test of the booster engines, so the booster will be tanked and pressurized. We also will tank the Centaur for this test, as it provides the needed ballast or weight, but Centaur will be kept at standby pressures. In addition to watching our live coverage, you can also follow progress at ulalaunch.com and on social media.
That's the methane purge line.
The count is currently in a planned hold. We have 2 planned holds in today's launch count, which give our team additional time to resolve any issues prior to entering the terminal count.
Yeah, Moto automation is awesome.
In a few minutes, launch conductor Dylan Rice will pull the team for the final go to pick up the count. As you can see, we are currently in a storm here at Cape Canaveral, so we are working through weather coordination with the Eastern Range and coordinating a new T0. We'll resume some of our commentary once we have more information, and we'll take a look at some of our live pad shots in the meantime.
Yeah, see the big lightning towers there? Cool thing is that if you, I mean, I don't know how, if you guys are watching on mobile, it's probably not a thing. There's wires that actually connect to them. The 4 lightning towers actually, so the 2 on the sides are connected to each other, and then they're connected horizontally, but there's actually a wire, they're actually holding up a square over the launch pad, but it's a square that the rocket actually flies through on the way up. The reason why is if lightning hits one of these things, it'll go down the cables, and they connect all the towers together. So basically giving the electricity multiple paths in any direction. Multiple paths in any direction to make sure that it doesn't arc to the rocket. Yeah, bad idea. Look at that. Oh, that's cool, man. Twin BE4s. Very nice. Very nice. How long is the firing supposed to last? If it's an FRF that's anything like the shuttle Hellfish, it'll only be for a couple of seconds. Kind of like a static fire. I think you need to fast forward. Preparing to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. Has a rocket snare lightning tower cables. What?
Discovery, go at throttle up.
Hey, Oki, tier 3, 99 month sub. I've got 99 problems, but a streak ain't one. Has a rocket snagged lightning tower kit? Never. That's never happened and it never will. Yep. And there's the methane, and then the hydrogen is over here. It's over here, bottom left of the screen somewhere. The hydrogen purge line. Keep in mind that it's the same hydrogen systems, albeit with a little bit more capacity, that fuel Atlas V. This flight readiness firing is being done from Slick 41, Space Launch Complex 41. This is Atlas V's pad as well, and it will be, the pad will have joint use as Atlas V winds down and Vulcan flights start to wind up. The pad can launch both types of rockets. It has commonality because it's a mobile launcher style pad. So all you got to do if you want to, all you got to do, like ground service equipment engineering, is some easy thing to do. Is just build a different mobile launcher. It's this thing that says ULA on the side, the dark gray thing, that's like battleship gray. If you build a different launcher and the launcher can accept all the interfaces, fuel lines, water systems, electronic stuff like that, you can make the same pad launch a different rocket. Oh, it's simple. Have you tried just building a better rocket, Fivehead? Astra could have with its sideways launch prominent. I think that actually would have gone under the wires. The flame trench goes to the opposite side of the pad as the flames, ironically. Yeah, the flame trench, it goes in that direction. Now, keep in mind, it looks like it's pointing at the liquid oxygen tank right there, the thing that says ULA on it. That's the LOX tank. The LOX tank is actually shifted out of the way. The flame trench, the flame diverter in the trench does not point at the LOX tank. That would probably be bad. It's kind of off into the left. It looks like it's pointing at it in this shot, though. That's the flame duct exit right here. And the LOX tank is probably about 200 to 300 feet, or about 100 meters that way from the flame diverter. I know because I've stood right there. It's a good ways away. It just looks like it's close because that thing is freaking gigantic. Note the staircase up on the LOX tank. That little catwalk up there. The staircase going up to the catwalk. Yeah, that LOX tank's way far away. Hinks, 39 months. Yeah, see? That's a much better picture. Thanks, ULA. Very cool. See what I'm talking about? The flame duct goes that way. The LOX tank's way over there. Oh. Getting some little bit of solid oxygen buildup on the gaseous oxygen vents. Actually, that could just be straight condensation. I don't think solid oxygen can exist down here now that I'm thinking about it. It's probably just ice. Probably just regular condensation. The launchpad that deals with methalox, hydrolox, carolox must be such a pain. Also has to deal with crew and cargo launches. It makes my head hurt even thinking about everything. Yeah, I know the guy that designed it, Salyut. I've talked to him. It is impressive. I'm just so used to calling anything that looks like ice solid oxygen because most of the time we see the rocket engines are up in space. So once again, we're in a 7-minute hold. They're coordinating a new T0 time. Keep in mind, this is not a rocket launch. This is a test. Basically, they're going to turn the engines on. It's a test flight readiness firing, FRF for short. I don't know if you guys noticed anything about that rocket. It's missing something. It's just basically a bunch of fuel tanks and engines stacked on top of each other. There's no payload on board. The payload would be up here. This is the first booster of its kind. This is United Launch Alliance new Vulcan class booster, or the Vulcan is the name of it. I like to call it Atlas 6 because that's basically what it is. They are basically going to, once that clock starts going, they're going to basically go to T-0 and do basically a simulated launch all the way up to engine ignition. The only thing different that it'll do is basically shut the engines off after a couple of seconds, from what I understand, and never let go of the rocket to let it fly. Those things should breathe some fire here, if everything goes to plan. Yeah, flight readiness firings are extremely rare. You don't really catch them very often. The last flight readiness firing that I know of, it was the space shuttle. It was probably Space Shuttle Endeavour or a Delta IV CBC, a Delta IV booster, which was down the road at Slick 37B. That's the last time I can think of one. And then probably the Atlas III. The Atlas III flight readiness firing in like the late 90s. And then before that, it was Endeavour in 1992. The H3 did a FRF. There you go. Okay, so there are other ones. Now, keep in mind, a flight readiness firing is a little bit different than a static fire, I guess. I mean, SpaceX has been static firing their rockets for a long time. But they static fire every rocket to make sure that it's good. A flight readiness firing basically is just a qualification test. Future Vulcan boosters shouldn't do FRFs or static fires. This is the only one just to verify that all the systems work before they actually go to launch the rocket. What's different to, say, a Falcon static fire? Now, here for Chocolate, keep in mind there's no like unified nomenclature for rocket testing terms.
Discovery, go at
So
throttle.
flight readiness firing is basically a static fire, but if we're gonna like quantify it, a flight readiness firing is once. You only need to do it once. Static fire kind of implies every single booster static fires. Is it just me, or the nozzles seem 3D printed? They're not 3D printed, Salyut. They're spin crafted, if I remember right. You know, you ever take you ever watch like a pottery? Yeah, or you ever done pottery before? You hit the pedals and the thing spins, and then you form the clay with your hands. Literally that, but with rocket nozzles. That, but with metal. Yeah, that's why it looks like it has the appearance of being 3D printed. It's not. They're not 3D printed like that. They're spun. You spin the nozzles, if that makes any sense. Yeah, I know it kind of has the same kind of like texture as like Relativity's core, but the thing is that what Relativity does with their core and spinning a nozzle is not that far off. But the thing about spinning the nozzle is that you start with basically they're like extruding the metal. It's literally like clay. That they start with a lump of metal and they extrude it up around a mandrel. Instead of like, so what relativity does is they have that same kind of thing. They have the same kind of table that spins, but they just have a welder that just zips the core together. New side project, got the go-ahead from client. I'm working part-time on a adult entertainment game. That's okay. What if this wasn't secured and took off? Nothing good would happen, Mock, if that's what you're asking. Mock, I'm not trying to single you out, but I always get those interesting questions. Oh, well, they're just trying to static fire it. What happened if it didn't static fire? Okay. That, like, what happens if it did static fire? What happens if it just let go? That would be like saying, let me think. Okay, that would be like getting in an airplane and the airplane having one wing, and then you'd be like, oh, what if you took off right now? Like, pretty sure someone would see something and be like, nah, we probably shouldn't do that. Either that, or if they still sent it and tried to take off a plane with one wing, I'm sure it would end well for somebody. It probably wouldn't end well for the people on board. You know what I'm saying? Like, hey, Rocket, great day to do his Vulcan static fire. The sun's coming out. It was just late. It's just afternoon Florida showers, man. Right? It happens. Oh. If I recall correctly, here's an instance of that exact thing happening. To be fair, Russia sent a rocket with a hammered computer upside down and still said, yeah. Thanks for these case scenarios. And it's really nice to know that, you know, you guys hold ULA on the same engineering standard as Roscosmos. Thanks. I'm sure they'd really appreciate that. I wonder if we'll get some thrust vector control checkouts during the terminal count. Yeah, some gimbal action. Yeah, maybe. I'm so ready to see the BE-4 fire. Yep. I'm with you, man. And Hellfish, that F-16 test was just... They weren't expecting the plane to take off, but it took off. See, okay, here's the thing. If the thing that you're engineering and testing does something that you don't expect it to do, like an F-16 taking off when you were trying to taxi it, that means it's doing something that you don't understand. And if your plane or spacecraft is doing something that you don't understand, that means it's doing something you probably don't want it to do. This, in rocketry, is called a failure mode. Failure modes are basically untested modes and configurations of the vehicle. If you experience a failure mode in flight, you've got a big problem. Apollo 13 is a good example of that. Yeah, that's a failure mode. Turns out when you drop the life support system on the ground and then just put it back in and say everything's fine, it explodes in certain circumstances. Untested phenomenon. Yeah. You only want the rocket to do what you've tested for and nothing more. So if your rocket and or plane and or whatever is doing something that you don't understand, it's probably in a failure mode and something bad's about to happen. Now keep in mind, there's nominality here, I guess. That's your word of the day. That's probably not a word, but there is... So in engineering, how much it fails. Like, if it does, rocket's never going to be exactly perfect to your simulation. It's never going to be right. How much is it deviating from what you tested for? If it deviates too much, failure mode. But there's usually an acceptable tolerance. Like, if the rocket makes it to a 100 kilometer by 100 kilometer orbit, right? And the rocket's in a 99 by 100 kilometer orbit, that's good enough. That's usually good. That's fine. Actually, 99 by 100 probably isn't, but there's nominal windows here. Nothing's ever going to be like exactly perfect. Wouldn't it be cheaper for these non-SpaceX companies just to pay SpaceX and use their Falcon boosters? Well, So two things, Loki. ULA is like a conglomeration that's probably like 5,000 staff strong. And a good amount of that staff is probably there asking that same exact question. Do you think they would have rolled out with a new booster if they... I mean, they're another launch provider. Don't you think they would have thought of this? Like, the second thing is that the Department of Defense and NASA usually don't like one rocket that does everything. They learned that the hard way in the 80s. Don't make one rocket, because if that rocket enters a failure mode, then you have to sit there and you have to figure it out before you won't launch any more rockets again. So we need 2 rockets with 2 different architectures for Department of Defense missions. So there's always going to be a need for redundant capability to kind of hedge your bets against not being able to launch in space. It's called assured access to space, and every defense department from every single country uses what I'm talking about. Does that make sense, dude? Yeah, they're another launch provider, dude. They're another launch provider. I'm pretty sure the other launch provider is, like, Chevy isn't going to look at like a Ford Mustang and be like, we should just buy that and then put a Camaro badge on it. That'd be fine. I'm pretty sure they're not going to do that. Do you know Destin from Smarter Every Day? I know of him, Mock. I've never met him, no. He's a great STEM guy. Destin's awesome. You and him should collab sometime, okay? Oh, they keyed the mics. It's pretty nice, Erdad. I like that part too. So we're still in a 7-minute hold. The test was supposed to be 45 minutes ago, but I think they had some nasty weather. I think they're just waiting for optimal weather conditions. Any idea how long this hold is? If I knew, I'd be in the Vulcan Spaceflight Operations Center. We need more rockets so we can shoot down that observation station. Yep. Yep, that's a good point, Zeno. It's a Stellaris joke, Byron. Ooh, if they could just leave this shot here, that'd be great. There are my engines, Jeff. That's right. Out of curiosity, can anyone create a satellite? Yeah, there's a lot of paperwork to fill out, Loki, but yeah. You just got to get the licenses for it. It's like getting your pilot's license or getting a driver's license. It's just a little bit more complicated. And the means to get that satellite up into space is expensive. Yeah. That's what commercial companies like ULA, SpaceX, Blue Origin, that's what they're trying to fix. Northrop Grumman with their rockets, Electron with Rocket Lab, that's what everybody's trying to fix. The big demand in the industry right now is basically just to find a cheaper way to put a satellite up there. Now, SpaceX does the economy of scale. Economies of scale with reuse. You can launch a lot if you reuse the booster, but And that is the lowest. That's probably one of the lowest prices in the industry. However, Falcon 9 is basically a loss leader. It's cheaper than everything else because it's reused, but SpaceX is in a lot of technical debt with it. Meaning that they engineered a system for the market that has no need. You don't need to do reusability. That's been ULA's argument for the longest time. They haven't pursued reusability up until Vulcan, and even Vulcan is just kind of partial reuse with jettisoning the first stage engines, which is what Vulcan will be designed to do in the future. ULA has always said we will pursue reusability if there is sufficient market demand that we could see a return on investment. Now, SpaceX is a little bit different. SpaceX has insane technical debt. Basically, they engineered something way too good. They engineered something that can supply an industry with not a lot of demand. So they do have the cheapest, and everybody that does want to launch into space usually uses them. However, SpaceX isn't necessarily about profit, right? The reason why Falcon 9 was engineered out and why it's too good for the industry is to sustain Starlink for the big one. The Falcon 9 is not supposed to generate revenue because SpaceX figured out that a little while ago that you're never going to see a return on investment from a rocket that's reusable, right? There's never going to be a high enough demand to facilitate a rocket launch almost every day. But if you build an internet satellite constellation, then you can get demand down to probably every week, right? Which is what they're doing right now. And now that favors economies of scale. That favors reusability, at least of your first stage, right? So SpaceX built something that was over-engineered to launch their own network. They made their own demand, essentially, right? ULA, on the other hand, is still just a launch provider. They don't have any in-house satellite production like SpaceX has Starlink. So partial reuse still makes financial sense for them. That's what makes the most sense for them to see a return on their investment. They're a for-profit company, and now don't get me wrong, SpaceX is as well. But SpaceX is willing to forego some of those profits to build a better launch vehicle, right? So Falcon 9 maybe broke even at best. For all the development, you're never going to see a return on investment. The return on investment comes maybe from Starlink, and even then it's just a push, probably. Starship, but SpaceX now retains an insane amount of technical knowledge on how to reuse boosters. That's why they're pivoting over into Starship. That's why they started the Starship program, to take all the things that they learned from building Falcon 9 and reusing Falcon 9 boosters, take all that technical expertise and rolling it over into Starship and building a fully reusable system so they can A, maintain Starlink, and then B, also go to the moon. NASA's paying them to build a lander. They're paying them a good amount of money, right? And then use this technology to basically make profit in the future. That's the whole idea. ULA, on the other hand, like I said, is not doing that. They are pursuing a safer avenue of rocket engineering where they build a vehicle that is based off of market demand rather than kind of hedging it on a bet like what SpaceX does. Would ULA be at all feasible without government launches? I don't see that as a bad reason to exist, just curious. Sure. ULA has done commercial launches, Admiral. I'm not sure about feasibility, but see, here's the thing. Admiral, asking a question like that is not understanding the history behind it. And I know you don't mean anything by it, so let me explain. 30 years ago, cast your mind back to 30 years ago. What's 30 years ago? 1993? So 93, 94, 95, 96. The industry is booming like it is now. Right? The industry is booming. There's commercial launches, tons of commercial launches, tons of high demand. And there is no... NASA's using the space shuttle, but they're using the space shuttle for scientific missions.
This is Vulcan Mission Control at T-minus 7 minutes and holding. As you can see, weather is improving as our team works to establish a new T0. While we wait, let's learn more about how the Vulcan rocket is built.
So, we'll look at this in a second. We've seen this video before, but if you're curious, I will go back. So, part of the reason why ULA exists is because that super healthy commercial market for launching stuff into space crashed with the dot-com boom in 1997. 97, 98, 99. The dot-com bubble burst. And the commercial launch industry went with it. Not good. So the demand for rocket launches, for commercial rocket launches in the 90s was trending upward, and then the dot-com bubble burst, and it literally went to zero. Like, nothing. So basically everybody had built these rockets that were designed for scale to do a lot of launches, and now they were stuck with these launch vehicles that were designed to launch like once every month, and now the demand went so bad, they went from projected launches of launching Deltas and Atlases every month to launching maybe 2 to 3 a year. That's how hard the market crashed. Now, there was some corporate espionage going on, and that did play something into it, but part of the reason why ULA formed is because Boeing and Lockheed Martin, Boeing with their Delta rockets and Lockheed Martin with their with the Atlas rockets, basically said there's no profitability here. We don't want to do this anymore. It's not profitable. We're literally pissing money, right? And the U.S. government said, no, you're not doing that. You guys are spying on each other. Now you work together. So to just forget about that whole spying on each other thing, Boeing and Lockheed merged their launch services into ULA, right? And they paid United Launch Alliance with a contract to maintain operational readiness despite the market demand going up and down. So the circumstances in which ULA has formed was basically because the government wanted to launch stuff into space, because the demand for rocket launches from the government is always sustaining. But the problem is that the demand for rocket launches from the government is only like 2 to 3 launches a year. See what I'm talking about? So asking would ULA be feasible? I don't know. Maybe. Possibly. It's possible. I mean, they've put themselves in a pretty damn good market position nowadays. ULA, the majority of ULA's profits, believe it or not, guys, does not come from government anymore. There's this guy that runs some jungle website or something. The jungle website. What was it called? What's that guy's name? He's shaved head. Something like that. Oh yeah, Jeff Bezos. I mean, don't get me wrong. This rocket is using Blue Origin engines, which is a company that is owned by him. But he also bought 9 Atlas V launches, bought out the remaining stock of ULA Atlas Vs, and then bought 38 Vulcan launches. 38. And then 12 New Glenn launches, and then 12 Ariane 6 launches on top of that. It was the largest block buy of rocket launches ever. Ever. Bigger than the Saturn V block buy, which is unbelievable. So, believe it or not, ULA and Amazon wants to do that because they want an internet satellite provider like SpaceX does, right? They want to make their own Starlink called Project Kuiper, right? So, yeah, dude, would ULA be feasible? Yeah, absolutely. Yeah, mostly because of Jeff Bezos, but yes, absolutely. There is ULA. The majority of ULA's profits come from commercial at this point, which is kind of nuts. Which is kind of the reason why they made this new booster in the first place. Yeah, 38 Vulcan launches. And the crazy part about this is that that's not a bad thing. You know why? ULA had always said if there is demand, if there's so much of a demand where we need to launch Vulcan rockets a lot, we will pursue reusability. And then when that contract came out, everybody was like, is this enough demand? And the ULA said, oh yeah, this is enough. So they're building more launchers, they're expanding their factory, they're building more mobile launchers, they're expanding their factory, they're building another integration building, and Vulcan is going to work on smart reuse, basically jettisoning the first stage engines and having them parachute down with an inflatable heat shield so they can be reused. It jettisons the engine section. Tori Bruno update. What's Tori Bruno saying? Around 20 minutes to T-minus 0. Cool.
And have placed their trust in us to do this. On our Cert-1 flight, we'll have a few payloads flying.
Out of all the rockets that are used in today's time, what rocket do you like the most?
Lunar lander to
Falcon
the surface
9.
of the moon. Amazon's Kuiper spacecraft, which will be the first in a series of many launches.
Vulcan technically isn't flying right now. It's not flying yet. When that thing starts flying, it will steal a little bit of that thunder. It's a really good rocket. Really, really good. And it's reusable. It's partially reusable, just like Falcon 9 is. It'll jettison that whole part in the back. The white part in the back, that whole thing comes off. In flight. Really, really good stuff.
To be able to be the mission manager for this launch. There's always a lot of honor to be a mission manager for everything
and it's got a
that
sweet
we launch,
paint job.
But there's just such a unique flavor here with Cert-1, knowing what goes into developing and fielding a new rocket. It's not every day a new rocket launches, and Vulcan in particular is just an incredible feat of engineering. Our team has dedicated so much of their time, so much of themselves. You can't build a rocket like the one sitting behind me without incredible people. And when you feel that rumble of those engines and this thing leaves the ground, I'm going to be a little emotional sitting on console trying to hold it together. So just really looking forward to what launching Vulcan means. Not only
that was an Atlas V, by the way.
To a lot of missions that rely on ULA.
Yeah, those two are going to light here in a second. Well, in about 20 minutes. So a couple of different questions. Detaching the engine is better than just landing the booster. Zeno, it's getting the engines back. If you can get them back with the first stage, it's a bonus. But those two things are by far, in a way, the most expensive part of this entire thing. The propulsion systems are always the most expensive by a long shot. The only thing that I can think of on a spacecraft that is more expensive than propulsion is a crew capsule. Something that moves humans. That is more expensive to make. Can you explain ULA like I don't know what it is? Spaceman, your timing is absolutely horrible. I literally explained like the entirety of ULA's history, and I finished with it about 30 seconds before you asked that. Dude, you gotta work on your timing, man. Dude, it was like a 15-minute talk about ULA and how it formed and how launch demand works, and then right when I finished, it was catching my breath. You're like, "Hey, can you tell me about it?" I'm like, "Ah, damn it!" But why mail? Are you serious? I just told you that a moment ago. No, ULA is a joint venture company between Boeing and Lockheed Martin. It is a commercial satellite provider, or commercial launches provider, like SpaceX. It's SpaceX's competition. The cool thing about it is because it's a joint venture between Boeing and Lockheed, ULA is kind of carrying the weight of all of like ULA is kind of the modern day. It's carrying all the engineering from the early parts of the space program. So like a Centaur stage. That Centaur stage is a new form of Centaur stage in a long line of Centaur stages dating back to the 60s. 1962 was the first Centaur stage flight, a Centaur-1. There was Centaur-1, and then Centaur-2, and then Centaur-3. I don't know why they skipped Centaur-4, but that one's called Centaur-5. Centaur-5 is amazing. It's an insanely good upper stage. Hydrolox balloon tanks. So that's Vulcan right there. You see them manufacturing the core stage on that huge jig, and then there's the metal brake, right? Centaur 5's tank walls are so ridiculously thin, you can stretch form them, and they'll show it in a second here.
To see this launch vehicle come
This is the stock footage. They'll show it in a moment. Prop components have kind of have insane lead times. It's both engines and internal components to the engine sector for what they do. Smart. Yep.
Precision and the attention of detail.
You see this thing with that huge lattice jig around it? That's a Centaur stage. The Centaur stage tank walls are about as thin as a soda can. Yeah, actually, yeah, that's about right.
First Vulcan.
See, there's the pants.
The production team spent countless hours assembling and testing and checking out the vehicle. And now
so how the Centaur stage works is that when it in flight, it relies on residual pressure inside of the tanks to stay strong, like a soda can. That thing is one of the best upper stages that will be flying soon. It's one of the best upper stages ever made. The BE4 is closed cycle erudite. It is a oxygen-rich stage combustion cycle with methane. Oop, ice fell off. Basically held up by stress. Yep, I wonder if they're going to mount computers for the first stage. Suppose they'll be jettisonable section and cut the wires on release. I mean, hellfish, if it was me, I'd be putting the avionics package down by the engines. Just saying. I mean, if you're going to jettison it, you might as well. Is it a flat top? It has no payload fairing on it, T-Man. There is a mass simulator up there. See this thing up here? It's basically a gigantic weight. This one is not launching. It's just a flight readiness firing. They're just going to turn the thing on and then shut it right off. But that is really rare for a ULA rocket. ULA doesn't static fire their rockets. They rely on the engineering and the laws of physics to not change, which they don't, to make it so they really only need to do this once. This is the only time you're going to see this, ever. You'll never see it again. You'll never see them do another flight readiness firing with Vulcan, unless this test doesn't go how they wanted. The point is that the first Vulcan booster is the only one that's going to do it. Second one will not.
Vulcan mission control at
So this is actually super rare.
Today's flight readiness firing tests the Vulcan rocket with its new BE4 engines. Let's learn more from ULA's BE4 Certified Responsible Engineer, Kurt Ingram.
It was Novus, yeah.
Hi there, I'm Kurt Ingram.
What up, Kurt?
I'm the Certified Responsible Engineer for the BE4 engines. I'm in our Decatur, Alabama factory, and I'm standing here in front of our first Vulcan rocket with our first 2 flight engines. When we perform our flight readiness firing with this rocket, we'll do the full countdown, tank the rocket, and then ignite the engines. The plan is to throttle up, hold that power, and then do a normal shutdown, and then all the, of course, post-shutdown detanking and safing activities involved with that as well. These engines use a lot of new manufacturing techniques, which is something that is important in these new rocket engines to improve manufacturability. It brings down the cost of the engine and increases the production rate. The BE4 engines use liquid oxygen and liquid natural gas. One nice thing about that is after you've tested the engine, it's very easy to clean up the engine and restart it again. It also has improved properties in the combustion devices, the cooling passages of the thrust chamber, and overall it's a propellant that we believe has a lot of promise and has a lot of benefits for the Vulcan
They don't
rocket.
want you seeing the smart reuse. See, it's blurred
These
out.
2 particular engines went through a rigorous test program in Texas. They
Hello.
had at least 2 acceptance firings to prove that they're ready for flight, and they successfully passed all those tests and were delivered to us and are now ready for launch.
What animal is making that noise? They're track mobiles, Bandit, but yes. Herb. Yeah, Sid. Tim, yeah. Yeah. Pros and cons about having more and more rocket engines. I mean, it really comes down to what you're trying to do. You know, you have one rocket. If your first stage is just one rocket engine and that thing doesn't work right, then you have no rocket engines, and that usually ends poorly. It's usually better to have at least 2. But, with that being said, there has been single-engine first stage launch vehicles. A Minotaur has a single engine for its first stage. It's also a converted ICBM, but hey, whatever. Still single engine. Still counts, man! Have you done any covering of Spin Launch? I cover stuff from Spin Launch when they have something to show, Loki. Yeah. They haven't had anything to show in a little bit of time. Is this integration building movable like Slick 6? No. Complex 41 uses a Vehicle Integration Facility, or a VIF for short. It is static. It's the launch pad that moves. The tooling for installing the BE4 looked a lot like the tooling for installing the RS-25. We know that there are ex-shuttle personnel working at Blue Origin, Novus, so, I mean, I wouldn't be surprised. Also, convergent design. Ares 1, I mean, Ares 1 would have been fine. There's that SRB wouldn't have had a problem. Just saying. Probably got the same tooling contractor. Most likely. Pacey, how does Vulcan's payload mass compare to Falcon 9? Vulcan can move more than Falcon 9 just simply because it's partially expendable. It doesn't need fuel for landing. So they can basically go till the tanks are dry and then jettison the engines and then they'll parachute back down. It can do a lot more. The Vulcan in the VC6 configuration is... It's a small rocket compared to like Falcon 9 is taller, for instance, but Vulcan's wider. And Vulcan can have attachable SRBs. So those attachable SRBs, any Kerbal players out there, they make a big difference, don't they? On paper, it's more than Falcon 9, but I wouldn't be surprised if Vulcan in the future could end up moving way more in an expendable capacity. Is this the same as a static test? Yeah, Area Man, it pretty much is. But the difference here is that a flight readiness firing is just, it's a qualification test, meaning that they're only going to do this once. They only do it with one booster. Because if you make every other booster in the exact same way as this one, well, this one worked. So if you make every other booster the same way, all the other ones should work too. It's a little bit of a different style of testing than we see from SpaceX. This is more kind of garden variety aerospace industry. So the testing is kind of less iterative, more all-up style testing, kind of like NASA. So yeah, the cool thing about this is that as long as this test goes well, you're never going to see a Vulcan do a flight readiness firing ever again. FRF kind of implies that you only do it once. It's a qualification test. I mean, Rocket Guy mentioned that Vulcan is 35 metric tons versus Falcon 9's fully expendable 22. I don't want to say those words on stream. Just tapping in from work, what are we looking at here? Vulcan flight readiness firing. What's the hold for? We don't know. But we do get some nice views. I mean, 27 in the VC6 configuration, Rocket Guy is nothing to sneeze at. That's no joke. It's pretty hefty for its size. They said planned holds earlier. Mm-hmm. Are ULA behind SpaceX? I assume with years of experience they should be a major threat. I mean, Spaceman, I don't see SpaceX securing a launch contract for 38 launches. Do you? But then again, that's kind of a loaded thing to say, because if you tally up all the Starlink launches that SpaceX has launched, it's a lot more than 38 now, isn't it? Boy. That's what I mean. ULA doesn't make their own demand. They are a launch services provider, and that's it. SpaceX makes their own demand for launches with Starlink, in the hopes that Starlink will be profitable enough to offset the cost and development of Falcon 9. It's a little bit different. Two different conclusions, two entirely different styles of testing, two entirely different ways of operating a commercial launch provider. But they both seem to be profitable, so... people say, oh, is SpaceX better, oh, is ULA better? Well, they're both here. They're both still here. So clearly they're doing something right. Right? Am I right? Clearly, they're both doing something right. They both still exist. The only reason Bezos didn't contract SpaceX is because they are a competitor and would get their information. I mean, Lucky, I'm not sure what that adds to the conversation, but all right. So BE4 is basically a methane RS-25. No, completely different stage combustion cycle, completely different propellants. You're comparing a diesel to a gasoline engine, Erudite. Hey, EJ, I just want to say that. Okay, you just did. I also think you hit the enter key too early, Space. Premature messageulation. It happens. Happens to the best of us. Don't happen to me. Just saying.
This is Vulcan Mission Control.
Vulcan Mission Control.
7 minutes and holding.
7 minutes and holding. All right.
Vulcan's first stage is powered by methane propellant.
See?
The use of this fuel has several advantages. As a highly efficient propellant, it delivers a high ISP, meaning more miles per gallon. It's non-corrosive and non-toxic, allowing for safer use at the launch pad compared to hypergolic propellants. It requires storage at a more manageable temperature and requires less storage capacity compared to hydrogen. It possesses clean combustion characteristics even at low throttle, simplifying engine reuse compared to kerosene fuels. Using an oxygen-rich staged combustion cycle, a single BE4 engine is capable of producing 550,000 pounds of thrust.
Damn it, Rhino.
The engines at the base of the Vulcan rocket are made by Blue Origin.
That sucks, Amanda.
Let's learn more from their team.
Let's learn.
The BE4 rocket engine is a 550,000 pounds of thrust, liquid oxygen, liquid natural gas, oxygen-rich staged combustion engine cycle.
That guy worked for
space is
SpaceX.
making sure it's affordable, and a key piece of that is going to be making sure the engine is also affordable and cost-effective.
It's difficult because the rocket engine produces a tremendous amount of energy, which puts the hardware.
He was a caster on a SpaceX cast.
It's a high-pressure environment, high-temperature environment.
Or maybe it was Blue Origin.
Parts.
I forget.
You have to design durability into the system. So pushing the material, pushing the system performance, pushing all the components.
The propellant combination that we run on is liquid natural gas and liquid oxygen.
Liquefied natural gas is one of the most cost-effective rocket fuels around.
The LNG is also a clean burning fuel, which is really important.
Dude, look at the
it's an incredible piece of
the thermal protection on the combustion
that we
chamber.
built here in Kent and that we test in West Texas and soon our Marshall Space Flight Test Center at 46. You can hear the rumble.
Yeah,
and
that guy.
feel
This
the
guy was on a
energy
Blue
of the
Origin cast.
BE4
That guy was on a
engine.
Blue Origin cast. Never mind. Forget what I said.
We put the engine through its paces. We try to break it on the test end so we know exactly what the limit of the design and build processes have become.
It's a pretty exciting time on BE4 at this point. We've completed all of our pre-qualification testing. We've moved into engine production.
Oh, did you see the beef on that damn
BE4
joint?
is going to be the workhorse of the 2020s and the 2030s.
To be able to support an engine through the development and production.
Damn, that thing's cool.
And seeing them integrated onto Vulcan and flying is going to be something that I will never forget.
Depends on the propellant, zombie, but yeah. I would clean the rocket motor out, yeah, absolutely. Sides of the booster, I mean, SpaceX doesn't. But then again, it depends on the propellants that you're using. You know, Falcon 9, when it lands, it gets covered in carbon soot because the engines are using kerosene, right? If you had some type of landable hydrogen rocket, say like Blue Origin's B3 engine on New Shepard, when it lands, there's no soot on the side of the rocket. You can't have carbon emissions when you're not burning carbon. That's your 5-head fact for the day. So it really depends. But components on the engines themselves do need to be serviced. Absolutely. Oh, yeah. I mean, we haven't gotten to the point where a rocket engine is like starting up a car engine. Just, all right, turn it on. Okay, we're good. We're not at that point yet. Maybe soon. Heck, even airplanes aren't even at that point yet, dude, right? Like, there's still a startup sequence to an airplane. I mean, some airplanes are getting pretty damn good.
This is Vulcan
Hello?
Mission Control at T-minus 7 minutes and holding. The launch site underwent significant modifications to make Slick 41 a dual-use pad to seamlessly handle both the Atlas V and the Vulcan manifests simultaneously. Some of the work shown here included a new methane storage area featuring 3 reservoirs, upgrades to the booster liquid oxygen transfer lines,
or the blocks lines,
larger cryogenic storage tanks
They're
for
not called
Center
that at
5's liquid hydrogen and liquid oxygen, and updated
maybe,
acoustic
Cam.
sound water system, and changes to the vertical integration facility to accommodate the larger diameter of Vulcan. The Cape also has a new dedicated Vulcan launch platform and refurbished a Titan area facility known as the Spaceflight Operations Center, or SPOC, to house the rocket.
Yeah.
The graphic shown here details Vulcan's journey to the launch pad.
What's up, James?
This new next-generation rocket provides a higher performance and greater affordability while continuing to deliver our unmatched reliability and precision. Once production is complete, the rocket transfers to our rocket ship and is transported to the launch site. Then our launch processing begins with our launch vehicle on-stand operation. After that, we'll proceed into our flight readiness firing, the milestone we're working towards here today.
Yeah, baby.
Once our testing has completed, we'll proceed into standard processing operations with our payload mate, and then countdown, fueling, and launch of the first Vulcan.
I mean, lucky rocket guy ain't wrong. Hell of a thing to have on your resume, though. But yeah, now, like, trying to have kids and raise a family and work 60 hours a week is... Yeah, that's... No. Yeah, no. Do you think rockets will always be action-reaction powered? Or will there be a more advanced way? That ion engines already exist, Zombie. But... I mean, action-reaction powered? What do you mean? Like, warp drive or something? Dude, if we can... With enough energy, you could turn goat piss into gasoline. Alright, so... Sure, if we have enough energy... Warp space and time. I mean, Earth does that. Earth has no problem doing that. Earth generates a lot of energy in the form of gravitational pull. I mean, there's also, like, Alcubierre drives, which... theoretically could work, but that has to do with negative mass density and positive mass density, basically riding a gravitational wave. But I don't do theoretical propulsion too much, man. The stuff that we actually see fly, like right now, that's what I kind of know, if that makes any sense. But even if we do invent some kind of warp drive, I'm pretty sure you don't want to warp right there. This isn't Contact, man, right? Like, there's no Jodie Foster here. Yeah, that's right, Hellfish. Yeah. I mean, Novus, if I was out in the industry, dude, I would work for SpaceX, but I'd do that for like maybe five years, something like that. Unless I was really into the work, dude. Just grind it out. Like, dude, if I was like...
This is Vulcan Mission Control at T-minus 7 minutes and holding.
Yeah, good call, kid.
Vulcan is a game changer for our customers. Gary Wentz, ULA's Vice President of Government and Commercial Programs, shares what it means for the future.
This has really been a team effort working across the country. Our Decatur team with production operations, our West Coast team getting ready and doing the preparations to be able to support future launches, and folks in Florida with launch operations, as well as our customer community that are likewise spread across the United States. Since we started the development of the Vulcan launch vehicle, we've been working hand in hand with our government customers to make sure that as we go forward in the design, it meets all the requirements. The Vulcan launch vehicle offers us a single configuration core vehicle to be able to fly all the spacecraft. Everything from our commercial satellite providers to our national security space customers.
Don't mess up!
And eventually our human spaceflight customers. I've worked in the industry for over 30 years, and you don't get the opportunity to launch a first flight of a vehicle that often.
Yeah, baby.
This is very exciting to be here and be ready to fire the engine on the launch pad for the first time.
Cool. So what do I think about spin launch, Lucky? I mean, it's a little bit of a far-fetched idea, but I also think that it's important not to knock new ideas. If they can prove the engineering and the math behind it works, and I'm pretty sure they've done that, I don't think it's right to be like, oh, that's stupid. If it's stupid and it works, then it ain't stupid now, is it? Nice, Ferry. AOD, that's called RS Rocket Ship. Yep. It's literally called Rocket Ship. The transport ship that they used to move the boosters around. Former Delta Mariner. Delta Mariner was its name for a long time. And then they switched it to literally Rocket Ship. They're also building a second one, by the way. Yep.
This is Vulcan Mission Control at T-minus 7 minutes and holding. As expected, when preparing for a new rocket, modifications have to be made to the launch pads. Renovations have been completed at Slick 41 here on the East Coast, but let's learn more about modifications planned for Space Launch Complex 3 on ULA's West Coast launch pad.
Yes, I would like to hear more.
My name is Paul Aragon.
What's up,
I'm
Paul?
the West Coast Launch Operations Director out here for Vandenberg Space Force Base. Behind me, you can see there's an Atlas vehicle sitting in our mobile service tower right now. As we bring the Vulcan vehicle in, we will certainly have to make modifications to the platforms and the doors, obviously to make room for the larger diameter of that vehicle.
Rocket
also,
HVAC
on
is
the
a
umbilical
big deal,
tower
dudes.
that's off to the right of the MST, that'll also get modified. We have umbilicals that'll be swinging over, making their necessary connections to both the booster and the upper stage of the Centaur and the payload fairing. Inclusive with this particular set of mods out here, we do have a fixed launch platform, which is different than our East Coast mobile launch platform. Ours will include a mast, just like the East Coast, all of which fully supports tanking, providing commands to the vehicle, and obviously eventually launching our vehicle. This is the locked storage area for the Atlas rocket. This will be the home to the Vulcan locked storage area as well. Off right down in front of me to the left is the booster storage tanks for Atlas. Those will become the storage tanks for the Centaur 5. We're gonna have to add some capacity for the Vulcan. We're gonna take away quite a bit of the Earth here, bring it down, and put a very large 250,000 gallon tank.
Sweet.
That'll include vaporizers and offload station, and that'll be home to our new Vulcan
We get it.
storage
You
area.
vape. Okay?
This is the side of the pad that has our fuels and our gas storage area. We do have water for deluge to the pad, but off to the left here and working backwards to the very far back is our gas storage area. And that'll have both our gaseous helium and gaseous nitrogen.
Cool.
We will be bringing in more of each of those because obviously the Vulcan rocket demands more. The yellow tanks you see back here, that's strictly for Atlas, RP1. Those tanks will be drained of their propellant, and then we will go ahead and remove those from the complex, and we'll bring in some of those vessels that we're going to use for gaseous nitrogen and helium.
Sweet.
If I go and I step back here on this side, this will be where we're going to have Centaur hydrogen. And Centaur is going to be bigger as well, so we're going to have to increase capacity. We're actually buying a brand new 70,000 gallon tank to complement our existing tank, and that'll make up the total volume that we need.
That's
to fuel
fucking
the
sweet,
Centaur
dude. I
vehicle.
love launch
Two
pads.
offload stations will be here, which is only one right now. And so that, again, will help us to be able to not only be ready for a first attempt, but be ready for multiple attempts.
Cool.
Right behind me, it's going to be home to our new liquid natural gas facility. It'll have a 250,000 gallon brand new tank. It'll have a knockout drum, an LN2 tank that'll do conditioning for the propellant, and then it has an offload station to include burn-off flares to take any of that gas that's either coming from the vehicle or the storage area and burn it off so that we can control anything that's going into our atmosphere. Well, thank you. I hope you enjoyed the overview here for the complex.
I actually did.
And look forward to modifications for Vulcan Centaur coming to the West Coast.
See, Paul's cool. Be like Paul. That guy's cool. Note how the hydrogen flare stack and the LNG flare stack were not near each other. There's a very good reason for that. Both of those explode very nicely. You don't want them near each other. Interesting, Amanda. Those aren't the type of rockets that I'm a fan of, but still cool. I can't be like Paul. I'm not smart enough. Yeah, if you say it like that, zombie, yeah, of course. If you think you're not smart enough, well, yeah, then you won't be. But is it that you're not smart enough, or you're afraid that you won't be smart enough? That's right, I called you out. Now what? Now what do we do? Guess we got ourselves a little bit of a standoff here, amigo. Where the American flag is the interstage. Yep. Mm-hmm. No, I'm not smart enough. I don't know rocket science. Well, learn it then! Jeez! Considering this is a .44 Magnum, it's the most powerful handgun in the world, I think you have to ask yourself one question. Do you feel lucky, punk? Well, do ya? How much longer?
This is Vulcan
7 minutes?
Control at T-minus 7 minutes and holding.
Of course he
Last
is.
year, ULA's Atlas V rocket launched the Low Earth Orbital Flight Test of an Inflatable Decelerator, or LOFTED, proving the capability for reuse on ULA vehicles. Let's hear more about this successful test.
The LOFTED mission demonstrated a lot of key aspects of full-scale engine reuse long-term for the Vulcan program.
Awesome!
It was really exciting to see it, all come together after years of hard work and dedication.
What we learned on LOFTED supports Vulcan reuse because we've proven that an inflatable aeroshell can now be packed, launched, deployed, re-entered, and recovered from the ocean.
And reused.
LOFTED is the low Earth orbit flight test of an inflatable decelerator. It's basically an aeroshell that's made up of two major components. The HIAD, or the Hypersonic Inflatable Aerodynamic Decelerator,
That's so cool.
and the Flexible Thermal Protection System. We've been using heat shields for re-entry for decades, all the way back to the Mercury program, but they've always been constrained by the size of the rocket. But with this inflatable technology, now we can pack a big heat shield in a small space and inflate it just prior to atmospheric re-entry. LOFTED had dozens of instruments measuring temperatures, pressures, loads all over the vehicle, and we'll use that data to anchor models and build more advanced HIADs and larger diameter HIADs for new uses throughout the solar system and here on Earth.
Oh, that's so cool.
Our plan for Vulcan reuse is to roll it into the baseline Vulcan configuration. We're going to continue to invest in the reuse program as it's a key aspect for Vulcan's long-term evolutionary future.
Vulcan reuse will lower the cost of launch by recovering and refurbishing the most complex parts of the booster. This year, in 2023, we're going to be finishing our preliminary designs for Vulcan reuse and entering into a test campaign with wind tunnel, drop tests, ocean recovery, and many other things that'll prove out the system design.
See that one that's floating?
Reuse is going to bring
went to
a lot of
space.
significant benefits to all of our customers. We know it's all about lowest dollars per spacecraft for these large constellations. And so reuse is an important lever for us
Sim,
to
what's
continue
going on,
to
buddy?
provide and drive down that lowest dollar per spacecraft, not only for our US government customers, but also for our commercial customers, specifically Amazon and the Kuiper program.
Sweet. Dude, Did you guys... So not only can they, you know... Are they planning on jettisoning that whole freaking thing, right? The thing's going to come back down. Did you see Lofted? Do you see the condition that it was in? It looked like it hadn't been through re-entry at all. The Lofted heat shield came through and it looked brand new. It looked like it hadn't been through re-entry. That one that was floating around in the water. Compare that to other ablator heat shields, right? The ablator heat shields they're charred, they're burned, there's scorch marks everywhere. Nope, didn't see that with Lofted. That actually, dude, that hypersonic inflatable heat shield is actually super, 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 super cool stuff. They even, dude, in the Lofted post-flight press conference, guys, they even talked about using those inflatable heat shields of bringing down ISS resupply vehicles that were formerly not reusable. So, like, reusing Cygnus and stuff. And then they even hinted that they could, down the road, if Lofted qualify, like, if they'd have to review the data, but if it was good enough to do it, it could bring back down ISS modules. Think about that for a second. Now that's cool, man. Why recover the engines as opposed to the whole booster? The engines are the most expensive part, Nova, by a long shot. Yep. Your super cool stuff. Oh. The ISS belongs in a museum. Yeah, well, there's a vehicle that built it that we could have used to bring the stuff back down, but...
Discovery, go at throttle up.
But, you know, we decided we want to do less things in low Earth orbit, not more. Wedding date? It's in a couple of weeks, Praga. No, I mean the unfrosted part, EJ, where the bulkheads are, right? Oh, down here? Yeah. This doesn't have a common bulkhead. So, yeah, there's the bottom of the LOX tank and the top of the LNG tank. Yep. What museum could house the ISS? The Smithsonian. I mean, Mutter, look, I'm not saying that we, you know, should put the ISS outside. What I am saying is that building an extension to the Udvar Hazy Smithsonian Annex and literally hanging the ISS from the ceiling of a gigantic room and having Discovery under it, one of the shuttles that built it, would, you know, probably be a really cool thing to do, and it'd probably be really good for STEM outreach. Why do they not have a common bulkhead? It is the temperature difference between liquid oxygen and liquid methane. Thermal issues shouldn't be bad with CH4. I mean, clearly it's enough to warrant a differential, two different bulkheads, Jock. But also at the same time, I'm betting you it's easier to make that. I mean, I don't know that for sure. I'll bet you it's easier to just make two different tanks and then weld them together. I mean, you got to remember. So think about, not you got to remember. Think about it like this. If in the future, the tankage is going to need to be really, really cheap, really, really simple, or inexpensive and simple to make. An inner tank design, so non-common bulkhead, is simpler to manufacture than integrated common bulkhead tankage. Right? So in the future, when they're reusing the propulsion sections, they want to be able to crank these tanks out as quickly as possible. A non-common bulkhead actually makes that pretty easy to do. They're easier to make. Yeah, Aqualux. The ISS fries. Like that, but with the real one, yes. They'd make a new wing at Wright-Patterson, just saying. I know it would probably never come here, though. Yeah, you guys don't deserve it.
This is
Wright-Patterson doesn't deserve it. You guys pulled out of the shuttle
7 minutes
program.
and holding. The Vulcan rocket we're seeing today has a distinctive look. Here's a
go do your Titan 4 things, right? No. Yeah, AOD, right? Spray on foam insulation. Primer. That is an awesome paint booth, might I add. You're masking off the tape lines, baby. Oh, that's so cool. That's how you paint cars, man. Some of what are tested on the side. Cool. Oh, dude, that's legit. Look at that freaking paint booth, man. Okay. So, Zombie, what do you mean? How come some are tested on the side and some standing up? So, vertical test stands will give you more realistic testing results. With that being said, building a vertical test stand is a little bit more difficult. You need like a flame trench, flame diverter. A horizontal test stand, you shoot the flames parallel to the ground, not at the ground, right? If that Starship test is any indicator, it shows why building a vertical test stand is kind of difficult to do. Because, you know, you don't have anything down there. Whatever is down there is not going to be as it was before when you fired the rocket engine.
Portions of the vehicle without ice are composite structures, or they're covered in SOFI, spray-on foam insulation.
Yeah, John, on the Saturn V, on the S2, they had to put an insulator on the common bulkhead. And that did add mass back in, but it didn't fully add all the mass back in from, you know, the mass difference that they had incurred from putting a non-common bulkhead on it. Who's the first launch customer on Vulcan, and when is it scheduled to launch? The Peregrine lander? A lunar lander is Vulcan's first mission, and then Dream Chaser, I think, right after that, if I'm remembering correctly. That's off the cuff, so that's probably wrong. But yeah, Vulcan's first mission is a lunar mission, believe it or not. Can I link a qualification hotfire? What company, Jock? Is it RFA? Pretty sure it's RFA. Is Dream Chaser ready? Tenacity is in final assembly right now, Mab. Yeah, pretty much. That's the two originally stated launches? Yeah, good enough. Yep, see it already? Oh yeah, RFA. Dude, big milestone the other day. Oh yeah, dude, I pay attention to all this stuff, man. It's just what I do. It's me. Why does everybody have to name spacecraft after Falcons? Yes. Bill, I'd like to add that Falcon 9 is not named after a bird, per se. It's named after the Millennium Falcon. Yeah, the spaceship. Yeah, Foz, that guy was cool. The old school sign painter. That guy was awesome. He does like surfboard art and stuff. It's so freaking sweet. And what is the Millennium Falcon named after? Time birds? Yeah, well, Mason, why don't we just name it Century Eagle? Or Year Buzzard? Or Day Pigeon or something? I don't know. Day Pigeon on something. Well, what? It's a unit of time and a bird. Donkey Sparrow. Wait, what? Second Sparrow has a ring to it. It definitely does. Pigeon 9 just doesn't have a ring to it. But Falcon 9 isn't named after a bird, man. That's what I'm trying to tell you. It's not named after a bird.
This is Vulcan
Minute
Control
Chicken.
at T-minus
That sounds
7
like
minutes
dinner.
and holding. Building rockets
sounds like dinner,
requires
man.
a large team, more than just the ULA team. At ULA, we have a team of over 45 suppliers that span 22 states. 20 suppliers in addition to
At least I
our
have
Colorado and Virginia
Eon
sites as well.
Albatross. I like Minute Chicken. That's the best one. Minute Chicken with minute rice. Chicken. It's what's for dinner. No. Beef. It's what's for dinner. Dun 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 dun. Yeah, now that song's stuck in your head. Yeah, I know, right? You know what I'm talking about. Hoedown? It's a good song. Yardbird 1. Good band. Holy crap, ULA actually is a supplier in my state. What could Rhode Island possibly do for them? Brown? Oh, no, that's UPS. Never mind. Just name it Yarg 9? No, we're not naming it that. No. Great. Now I need to find a Winn-Dixie. Yeah. Are we lighting this candle today? Well, they were supposed to do it a couple hours ago, but, ULA's waiting on something. There's something that's protracting the hold release. Also, protracting. It's a word. Shh. Minute Chicken would be a great test stand name. Doesn't really fly, but it makes a lot of noise. Would you like to see Launchpad fueling in Frost Lines in KSP2? Or in your opinion, does that stray too far from the soul or simplicity? That's... Nah, just stuff to make the rocket look cooler. You don't need to... Nah, it's fine. How long is the window? I don't think there's any window for a flight readiness firing, but not 100% sure. Yeah, fueling the rocket up would... Only nerds like me and a couple of other people here like doing stuff like that. Most people just like putting their rocket on the pad and hitting the go button. I mean, it's funny, you know, doing that in Kerbal, when you put the rocket out on the pad and hit the go button, it usually blows up, right? That's usually the case in real life, too.
Control at T-minus 7 minutes and
just
holding.
send it doesn't really work too well in real life.
The Vulcan Centaur rocket was developed with a low-risk path to first flight. 90% of the capabilities and designs of the Vulcan rocket will be flown before the actual first flight. The program was developed by leveraging our heritage vehicles, Atlas and Delta, and using some of those technologies to give us this heritage experience and flight heritage as we lead to the initial ILC. So as you can see, some of the items like the payload fairing, the pressure stabilized stainless steel tanks, and structurally stable aluminum tanks go all the way back to our heritage vehicles. In addition, we've on-ramped some capabilities over several cut-ins of the Atlas and Delta vehicles to get us some flight heritage here over the last several years. Some of those capabilities included updating our payload fairing manufacturing process and modifications, now flying dual RL-10 engines, updates to our common avionics system and software, and then most recently implementing new SRBs that have flown first on the Atlas vehicle. So ultimately, here at our first flight, we have several flights across all of these components, and the BE-4 engines are truly the first flight component on the Vulcan vehicle.
I love how it says for the RL-10's heritage. The first RL-10s came around in 1962. Yeah. Pretty good heritage. The RL-10A, yeah. Baseline config, 1962 Atlas Centaur. True story. It's a pretty good motor. We've used it basically since the dawn of manned spaceflight because it's that freaking good. No Centaur? No, there's a Centaur on there. It has a weight on the top. That's why it looks weird. Do you think Vulcan will be dead on arrival? No, not at all, Back Alley. ULA has already secured contracts for, off the top of my head, easily over 40 launches for Vulcan. It is probably one of the furthest rockets from DOA ever. Seriously, can you name another rocket that had 40 plus launches locked in before it flew? I'm sure there's some. I'm sure there's one out there somewhere, but... And somebody asked if I've ever played RP1, RSS RP1 in Kerbal 1. I've never done it on stream. Yep. What about the RL-10 makes it so good?
This is Vulcan Mission Control
She
at
has to talk,
T-minus 7 minutes and
right when you ask a good question.
ULA's Atlas rockets have launched many of the world's vital space assets. Let's take a look at the impressive legacy of the Atlas family of rockets, which has significantly contributed to the development of Vulcan Centaur.
And the RD-180 engine roars to life and liftoff of the maiden flight of the Atlas V rocket with a Hotbird 6 spacecraft on board.
As the inaugural flight of the Atlas V lifted off on August 21st, 2002, it carried with it the dreams and aspirations of thousands of rocket pioneers who had laid the foundation that made it possible.
It's a good rocket.
Atlas V continues the Atlas legacy of innovation and accomplishment that has been vital to our nation for more than half a century. Named after the mighty giant of Greek mythology who carried the world on his shoulders, Atlas was conceived as a weapon and a deterrent, but evolved into a system that pushed the envelope with trailblazing innovation and steadfast reliability. At the request of the Air Force, Charlie Bossert and his San Diego-based engineering team began work on a demanding set of requirements to design an intercontinental ballistic missile capable of delivering a 1,500-pound warhead to a target 5,500 miles away. Their answer, which became known as Atlas, was the top national priority in 1955 as the race with the Soviets engulfed the country.
See that
On
Convair
June
factory?
11, 1957, the first Atlas flight lifted off from Space Launch Complex 14 in Cape Canaveral, Florida. The flight ended 38 seconds later, but Bossert's team had taken the first step and proven the structural integrity of their innovative pressure-stabilized steel tank. Complete success for the Air Force and Bossert's team would come just 5 months later, on December 17, 1957.
The SM-65.
Go, honey, keep going, baby.
Keep going, baby! That's awesome.
Though the Soviets had beaten the U.S. to space with the launch of Sputnik in October 1957, President Eisenhower would counter a year later when Atlas 10B delivered his holiday message of peace from orbit 180 miles above Earth. Known as Project SCORE, the orbiting Atlas booster became the world's first communication satellite.
This is the President of the United States speaking. Through the marvels of scientific advance, my voice is coming to you from a satellite circling in outer space.
cool.
Attention all personnel, report to the blockhouse immediately. Countdown will begin.
On September 9th, 1959, Atlas 12D became America's first operational ICBM, following launch from California's Vandenberg Air Force Base. In all, 350 Atlas ICBMs were built and stood on operational alert through 1965. The surplus boosters were refurbished and used by the Air Force, the Army, the Navy, and NASA. The last refurbished booster was launched in 1995. By the early 1960s, the Atlas booster had made the transition from missile to space launch vehicle, and 1962 proved to be a pivotal year. Riding atop an Atlas booster in Project Mercury's Friendship 7 capsule, John Glenn became the first American to orbit the Earth on February 20th, 1962. Three additional Mercury flights, carrying astronauts Scott Carpenter, Wally Schirra, and Gordon Cooper, set the stage for the Gemini flights and the Apollo missions to the moon.
Yeah, but that's Surveyor.
Later that year, Atlas scored another first when Atlas 179D, equipped with an Agena upper stage, lifted off from Space Launch Complex 12 at Cape Canaveral. Its payload, NASA's Mariner 2, became the first successful interplanetary spacecraft. 1962 also marked the debut of the Centaur upper stage, the first to harness the power of liquid hydrogen. The Centaur upper stage, to this day, remains a hallmark of the Atlas system. Together, with its Agena and Centaur upper stages, the Atlas booster went on to play a significant role in America's exploration of the solar system, launching virtually every exploration mission in the 1960s and 1970s.
It was the first spacecraft
They're vernier thrusters, Major,
that had enough energy to escape the entire solar system.
During the late 1970s and 1980s, Atlas continued to play important roles in the development of our nation's space program. In addition to building our national security presence in space, converted Atlas boosters also launched the Air Force's Navstar demonstration satellites, leading to the navigation system known today as GPS.
So cool.
In the late 1980s, General Dynamics saw an opportunity to bring commercial payloads back to expendable launch vehicles, and on July 25, 1990, AC-69, the first Atlas I, ushered in a new commercial era for Atlas. The commercial era brought 8 new Atlas configurations over a 14-year span, each carrying an operational payload. The commercial program has enabled breakthroughs in communications, meteorology, broadcast technology, navigation, and national security. In 1995, development of the Atlas III vehicle began. In a bold move, the Atlas booster engine system was replaced with the powerful RD-180, which generates 860,000 pounds of thrust and has throttle capability, resulting in a smoother and more efficient ride.
Air start, Hellfish, yeah.
Making its debut from Space Launch Complex 36 on May 24, 2000, the Atlas III provided a substantial performance improvement over the Atlas IIAS. Reliability was increased by reducing the number of engines from 8 to 2 and the elimination of 5 staging events, as well as more than 10,000 parts.
This is Atlas Mission Control on T-minus.
In 1998, the Atlas team embarked on a development project for the United States Air Force that would forever change the Atlas vehicle.
And the RD-180 engine roars to life and liftoff with a maiden flight of the Lockheed Martin Atlas V rocket with a Hotbird 6 spacecraft on board for Eutelsat in Paris, France.
For more than 40 years, Atlas vehicles had relied on the pressure-stabilized steel tank developed by Charlie Bossert and his team. In a departure from conventional thinking, the Atlas V development replaced the tank with a structurally stable common core booster. In addition to vehicle modifications, the team took a new approach to processing and launch. Atlas V processing is done vertically, and the mobile service tower has been replaced by a mobile launch platform, which carries the entire assembled vehicle to the launch pad, ready to fuel and launch. The Atlas V is expanded to multiple payload fairing and solid rocket booster configurations, as well as re-establishing a launch capability from the West Coast at Vandenberg Air Force Base. The Atlas vehicle has a long legacy of accomplishment. This record of success, which is nearly unparalleled in the launch industry, is built on the lessons handed down from more than 60 years of Atlas experience. It is also a credit to the dedication and persistence of the Atlas team and their passion for mission success, one launch at a time.
Sun's going down. Nice backlighting. Yeah. The reason why Tech, if that didn't answer it, the reason why they still use the RL-10s is because RL-10s are simple rocket motors that are extraordinarily efficient, and for the efficiency, the performance is good enough. They're basically great upper stage motors. The interesting thing is that the RL-10 was really designed as a throttleable solution for a lunar lander. But when they figured out that trying to make sure that hydrogen doesn't boil off on the way out to the moon, they realized it makes a better upper stage engine than it does a lunar lander engine. Not saying we still couldn't do that, just saying, figure out the boil-off problems. The RL-10's probably about as good of a landing engine as you could get. But, yeah, it is ridiculously simple for what it is, and it's extraordinarily reliable. For an RL-10 to not work, physics needs to stop working.
This is Vulcan Mission Control at T-minus 7 minutes and holding. ULA's Delta IV Heavy is the nation's proven heavy lifter.
Cycle, that's right.
Let's take a look at the evolution of this impressive rocket.
Yes, let's. Oh, Delta, my beloved.
Though first launched in 1960, Delta's story really begins in the mid-1950s with the development of the Thor Intermediate Range Ballistic Missile. Named after the Norse god of thunder, Thor was created in response to a growing fear that the Soviet Union would beat the US in the deployment of a long-range ballistic missile. The goal was to design a system that could deliver a nuclear warhead to a target 2,300 miles away, the distance between the United Kingdom and Moscow. On January 25, 1957, the first Thor lifted off from the newly constructed Space Launch Complex 17 in Cape Canaveral.
Oh.
Following a series of
failures, there's that.
The Thor team celebrated their first success on September 20th, 1957.
Hey.
In all, 59 Thor IRBMs were launched, with the last flight occurring in 1975. Thor began the transition from missile to space launch vehicle in 1958. On October 11, 1958, America's newly formed space agency marked its inaugural launch when Thor Able boosted NASA's Pioneer 1 on a mission to the moon, and NASA's long partnership with Thor was born. NASA and the Douglas Aircraft Company began development of the fourth and longest-lasting Thor configuration in April 1959. Using a Thor first stage and a Vanguard second and third stage, Delta I lifted off on May 13, 1960 from Cape Canaveral Space Launch Complex 17. Though its first launch was not successful, the Delta team quickly pinpointed the failure.
Look at that handmade PCB.
3 months later, delivered NASA's Echo 1 communications satellite to orbit. Following Echo 1, the Delta team racked up an impressive 22 successful launches. Led by Bill Schindler, the Delta rocket earned its industry workhorse moniker for rapidly establishing itself as one of the most reliable and versatile launchers. During the 1960s, Delta launch vehicles paved the way for the burgeoning communications industry, launched America's first weather satellites, and sent probes to explore our universe.
One Brown had nothing to do with
AT&T's
this.
Telstar 1, the first commercial communications satellite, launched in 1962, and in 1963, SYNCOM-2 became the world's first geosynchronous satellite. TIROS, or Television Infrared Observation Satellites, provided the National Weather Service with humans' first view of the Earth's cloud cover. In orbit around the Earth, Moon, and Sun, NASA's Explorer satellites provided us with a deeper understanding of the solar wind, cosmic rays, as well as Earth's magnetic field and radiation belts. By the end of the decade, Launch vehicle modifications, including the addition of solid rocket motors and an upgraded third stage, made it possible for Delta to orbit satellites 10 times larger. The 1970s was an international decade for Delta, as the manifest included scientific and communication satellites for several countries across North America, Europe, and Asia. Perhaps the most demanding challenge of the 1970s was the launch of the Earth-imaging Earth Resources Technology Satellite, later known as Landsat. The mission for the Earth Sciences community required major changes to the Delta propulsion and guidance systems. During the 1980s, Delta continued its reliable service to the communications, weather, and Earth imaging communities. As capable as the Delta rocket proved to be, production came to a halt in the early 80s when national space policy dictated that the space shuttle be used as the U.S.'s primary launcher, signaling the end of the expendable launch vehicle. But in 1987, the Delta team picked up where they left off, and development began on a launch vehicle to support the Air Force's Global Positioning System. On February 14, 1989, Delta 184 began a new chapter in space launch history as it lifted off from Space Launch Complex 17, demonstrating an incredible feat. The Delta II had gone from development to launch in just 2 years. To accommodate the larger GPS satellites, engineers improved the Delta rocket in several ways. The fuel tanks were stretched, a new payload fairing was developed, and larger solid rocket motors were incorporated. The modifications resulted in increased performance and flexibility.
Delta II was the Falcon 9 of its day, guys, for real.
By the mid-1990s, the Delta II had delivered the fully operational 24-satellite GPS constellation. And though it was developed for the Air Force, Delta again became a reliable partner to both NASA and its commercial customers. Over the course of its more than 20-year run, the Delta II has launched some of America's best-known scientific and exploration missions.
+4, 3, 2, we have main engine start, 0, and liftoff of the Stardust spacecraft. Liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Liftoff of the Delta II with Grail. Journey to the center of the moon.
On the commercial side, Delta II launched the Global Star and Iridium constellations, which brought satellite telephone communication to the world. Continuing its evolution to meet the growing demands of its satellite customers, the Delta team developed the more powerful Delta III. Though short-lived, the Delta III doubled the performance of the Delta II.
Ignition and liftoff of the Boeing Delta III rocket.
Stage systems looking normal. Engine burners keep burning normally, and all 6 ground.
In partnership with the Air Force's evolved expendable launch vehicle program, the Delta team began development of the next-generation Delta rocket in the mid-1990s.
And we have liftoff of the first Boeing Delta IV rocket carrying the W5 telecommunications satellite for Eutelsat of France.
All Delta IV configurations begin with the common booster core, powered by the RS-68A main engine. The Delta IV Heavy, with its 3 common booster cores, deliver our nation's largest missions to orbit.
Liftoff of the United Launch Alliance Delta IV Heavy rocket, carrying the NROL-32 mission for the National Reconnaissance Office.
Delta IV launch vehicles are produced at a 1.5 million square foot state-of-the-art facility in Decatur, Alabama. Processing and launch takes place at Space Launch Complex.
Guys, just a little bit of an update here. There was a lightning event during the planned hold that triggered a red line and retest criteria. Ran it through. Still, it's sorted out. Finalizing the steps, recycling, and heading back to the count very soon. From Tori Bruno.
Launch vehicle. Delta has reliably supported our nation for more than 60 years. Delta's legacy as a workhorse continues today and is a testament to the persistence, dedication, and commitment of an enterprising team that has continually evolved the Delta rocket to support a changing world.
5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket.
pretty much poison. And that's why I want to keep Delta's name going. So SLS is Delta 5 for me because it uses a Delta 4 upper stage, at least in the early configurations. And taking the upper stage from Delta 3 to Delta 4 kept the Delta nomenclature despite the architecture of the rocket changing completely. So, per Delta naming convention criteria, SLS qualifies as a Delta booster. And because Delta goes back to you could trace its roots right back to the Thor missile program in the 50s, like what you just saw. You know, to keep the streak going, SLS is Delta 5. Okay. No, you're not changing my mind. No, it's my stream, so you're wrong.
This is Vulcan Mission Control at T-minus 7 minutes and holding.
Mojave's awesome demo.
ULA also launches Atlas and Delta rockets here in Cape Canaveral, Florida. Let's take a look around.
With missions launched to every planet in the solar system, as well as critical national security,
Vulcan is Atlas
science,
6.
weather and communication
Because it's got a Centaur
ULA
upper
has
stage.
established a long-standing reputation for reliability and orbit accuracy in the space launch industry. At our launch site in Cape Canaveral, Florida, the story
launches from the same launch
ULA's
pad, man.
Atlas and Delta rockets arriving
Delta,
on the RS rocket
it's
ship.
Atlas 6.
The rocket ship is a specially designed cargo ship used to transport rockets from ULA's 1.6 million square foot production
Wait, there was a
facility
truck in
in
my
Decatur,
parking spot.
Alabama.
Wait, what?
Rocket ship is large enough to carry a complete Delta IV heavy rocket. That's 3 boosters, a second stage, and a payload fairing. Once loaded, rocket ship departs ULA's dock and travels through the Tennessee River, then onto the Ohio and Mississippi rivers, then goes out into the Gulf of Mexico. From there, the ship travels through the Atlantic Ocean, around the southern tip of Florida,
Then what is Ares
and
5?
north to Port Canaveral. Rocket ship was designed with several features to ensure successful delivery,
Well,
including
Ares
the
5 was
ability
never
to
made,
adjust its
so.
draft for shallow water and rudderless steering, which minimizes the need to tug. Atlas V boosters are transported from the ship to the high bay in the Atlas Spaceflight Operations
I've
Center,
been there.
or ASOC, for final preparations.
Third.
Delta IV boosters are moved to the Horizontal Integration Facility, or HIF, where they are mated together to form the Delta IV heavy
There you go,
configuration.
Alpha, yep.
With final checks completed, the boosters are transported to the launch pad for Launch Vehicle on Stand, or LVOS.
No, Lada.
The 107-foot-long Atlas V boosters are brought to Space Launch Complex 41 and are hoisted into a vertical position using a crane and placed onto the Mobile Launch Platform, or MLP, in the Vertical Integration Facility, or VIF. Delta IV heavy rockets are raised vertically by a fixed pad erector at Space Launch Complex 37.
Don't say
the
it,
fixed
Scott.
pad erector uses a single hydraulic piston to rotate the boosters 90 degrees inside the Mobile Service Tower, or MST. LVOS is followed by the addition of solid rocket boosters, and then the second stage. Next comes Wet Dress Rehearsal, or WDR, which is an end-to-end launch simulation, from fueling through spacecraft
That's
separation.
right there, Fear.
Meanwhile, the ULA team is also
That was
working
Parker Solar.
simultaneously to help the customer encapsulate their payload into the rocket's payload fairing. The encapsulated payload fairing is the final piece to be mated to the rocket. With the rocket stack complete,
did demo.
the
Stratolaunch
spacecraft
got
team
it.
tests all of the interfaces with the rocket and the launch pad. Once the rockets are completely assembled, final launch preps begin. For Atlas V rockets, launch countdown begins with moving the rocket from the VIF to the pad. The quarter-mile trip uses 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and
The
rocket.
Trackmobile.
2 rail cars
See the
lead
retracted
move,
wheels?
with the payload van
Cool.
providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the portable environmental control system provides air conditioning to the payload and rocket. Finally, Trackmobiles provide the power to move the 3.5 million pound convoy. For Delta IV heavy rockets, the process looks quite different. Approximately 9 hours before T0, final preparations begin as 40 hydraulic cylinders at pressures nearing 3,500 psi move the 10 million pound MST. It's first raised 8 inches and then rolled back. Delta uses a carriage transporter system, traveling at about a quarter mile per hour. It takes about 25 minutes to roll the MST to its launch position, 345 feet north of the Delta IV rocket. The Delta IV rocket stands 217 feet tall, or about 21 stories, and weighs more than 900,000 pounds fully fueled. On the day of launch, nearly 30 engineers and managers are polled for system status and readiness to proceed.
Status check to proceed with terminal count, Atlas systems, propulsion.
This is the final status check before launch for all Atlas and Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants.
Range coordinator. Clear to proceed. Launch director.
Launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count.
If the rocket is ready for flight and the weather is within the launch commit criteria, then polling will be completed and the team will have given the go for launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There's ignition. And liftoff of the United Launch Alliance Atlas V rocket.
For a typical Atlas V flight, the main engine and solid rocket boosters ignite to lift the rocket off the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path, minimizing the dynamic pressure the vehicle experiences during flight. Within the first few minutes of flight, the vehicle reaches Mach 1, the speed of sound, followed by jettison of the solid rocket boosters. About 4 minutes later, propellant levels deplete and the booster engine shuts down, followed by release of the booster stage. At various times in flight, depending on the mission, the vehicle jettisons its payload fairing. From there, the second stage will continue carrying the spacecraft towards its destination with planned engine starts and stops. Finally, Centaur will release the spacecraft in its target orbit to continue its journey.
Cool. And somebody asked why they spin the spacecraft. There was some of that some old footage showing them spinning spacecraft. Well, you don't need a stabilization system if you spin the spacecraft. Seriously, that's it. You want it gyroscopic, you gyroscopically stabilize it, basically rifling with the payload. Like how if you shoot a bullet out of a firearm with a rifled barrel, it spins the bullet. Gyroscopically stabilized. Do the same thing with spacecraft. You want the spacecraft to stay pointing in one direction, spin it, and then let it go. It will never stop spinning unless something hits it. In which case, something will still be spinning, but yeah, it'll never stop. Crazy, right? Now, I know what people are going to say. Well, what if they need it to stop spinning? Well, they can change the RPM and basically can get the thing to stop spinning by hitting the time warp button. Oh, wait, no, that's Kerbal. No. They actually have yo-yos attached to the side. Not like actual yo-yos, but they have basically a weight that's on a string. And when it's spinning, they let them go. And the spinning, the outward force, makes the weight, go away. It goes away from the spinning spacecraft, but it's on a string, so it stays there, right? It actually increases the moment of inertia. And increasing the moment of inertia will cause lower RPMs. Think of figure skater. You ever see a figure skater going around like this? They have their arms out like this, and then they pull their arms in and they start spinning really fast? The opposite of that. Yep, physics. I know. See how Hydra in your last for some EUS stuff, okay? When you turn a CD player on in space, that's self-gyroing, something like that. Does it have G-Shock protection, though? Spinning also helps with cooling. Lower revolutions per minute, officer, on certain missions. Yeah, absolutely. Sure. Uniform heating. Yep. Spinning that fast probably isn't going to do anything, but a slow barbecue roll? Absolutely. EUS flight hardware. Oh. Very nice. Very nice. I didn't come here to learn things. Well, too bad. What does the X-37B do on orbit? Oh, no, but that's really simple. What the X-37 really does, like, if you really want to know, I mean, you got to keep it on the down low, but what it actually does is And that's actually what it does. It's really interesting. Yeah. What? You didn't hear that? You really didn't say anything, did you? No, I gave an explanation, just like I always do. Hotel knows. Hey, you driving along. All of a sudden, the kid's in the back seat. I gotta go to the bathroom, Daddy. Not now, damn it. Truck tire. I can't stop. How long is this hold? Yes. You still have the Stellaris title. No, you need to hit the refresh button. There's a cliff. Oh my gosh, I can't feel my legs. The medic comes out and goes, oh my God. Are we there yet? No! Stuff's on fire, yo. New guy's over the corner puking his guts out. Ugh! All because you wanted to save a couple extra pennies. Get out. Now. You validate? Now! You guys finishing the quote in chat. It makes my day, man. Up. Gonna say something?
This is Vulcan Mission Control at T-minus 7 minutes and holding.
Hey, we're still here.
We just received confirmation from launch conductor Dylan Rice.
Dylan.
Our new T0 is 9:05 p.m. Eastern Time.
20 minutes. Well, more or less.
ULA builds Atlas, Delta, and Vulcan rockets in a 1.6 million square foot facility in Decatur, Alabama. Here's a look inside.
Successfully launching missions to every planet in the solar system, in addition to critical national security, science, weather, and communication satellites, ULA has established a long-standing industry reputation for reliability and orbit accuracy. While our rockets lift off from launch pads in Florida and California, the journey to space begins in Decatur, Alabama. At approximately 1.6 million square feet, ULA's production facility is an always-on workhorse where technicians simultaneously build components for Atlas V, Delta IV Heavy, and Vulcan Centaur rockets. Booster production begins when large aluminum plate stock is loaded into one of 4 double gantry skin milling machines, where aluminum is milled into patterns designed for building tanks and other components. This process helps reduce the original weight of each panel by 70%, while maintaining approximately 75% of the original material strength. After machining, skin panels are transported to the brake form and bump pressed into the precise curved radius required to create fuel tank barrel sections.
How strong that press is.
Components made from aluminum require anodization to protect from corrosion. For this requirement, certain components, like skin panels, are first given a high-pressure wash and then dipped in a series of chemicals to complete the sealing process. Skin panels are then transported to the vertical friction stir welder, where they are lifted and forged together to form the barrel sections of the fuel and oxidizer tanks. Delta IV and Vulcan Centaur tanks are comprised of 5 skin panels, while 4 skin panels form the Atlas V tanks. Friction stir welding is a unique process accomplished by a pin tool, which applies frictional heat and stirring of the parent material to form a weld. This process only uses friction as the heat source and has no filler material, making an extremely strong welded joint. Completed aluminum barrel sections then move to the circumferential friction stir welder, where domes are welded to each end, completing the first stage fuel tanks.
Dude, I've seen this footage before. I don't care.
After pressure testing, which verifies the integrity of the welds, the next stop for booster fuel tanks is the spray-on foam insulation booth, or SOFI. This is where completed tanks are primed, then insulated to protect from the acoustics that occur at liftoff. Tanks then move to final assembly, where components like wiring and engines are added. In addition to the first stage or booster stage, ULA's second stages are also built in Decatur. The factory has recently undergone a major reconfiguration, resulting in a new state-of-the-art Centaur 5 production line to increase the speed at which Vulcan Centaur second stages are built, assembled, and tested.
You guys like saran wrap? You guys know when you take saran wrap and you pull it over something to put it in the fridge? Watch.
Making it the most efficient upper stage.
They do that with stainless steel.
To create the domes or bulkheads for Centaur's 2 tanks, gores or pie-shaped sheets are welded together. The bulkheads and tank skins are then assembled using a combination of spot and seam welds.
Very
Spray-on foam insulation, or SOFI, is then applied to the Centaur tank to provide thermal protection for the cryogenic fuels. Centaur's tanks are known as pressure-stabilized tanks because 90% of their weight and structure at launch is from the mass of the fuel and oxidizer loaded prior to liftoff.
That's a very nice mass fraction.
The Centaur tank then moves to final assembly, where engines, avionics, pneumatic, and propulsion systems are installed. At the end of the production journey, all systems on both the booster and Centaur are fully tested, and the stages are prepared for transport to the launch site. With testing and transport preparations completed, Atlas V, Delta IV Heavy, and Vulcan Centaur rockets exit the factory and roll about a mile down the road to a dock on the Tennessee River.
Dude, for the truck nerds, if there's any truck nerds out there, see that gray truck? That's a Ford L9000. That ULA has paid to restore their 2 L9000s that they have because they're that good of a freaking truck. It's a heavy-duty truck that can pull, it's a heavy-duty truck, but it has a day cab on it. Those are super rare, I guess. So they restored those old Ford L8000s or L9000s, I think is what they're called. They're really cool trucks.
Slick 41, so that it can support both the Atlas and Vulcan launch systems, making it the only operational dual-use pad.
Drone cam?
As you can see here, this is the noob launch platform that is specific to the Vulcan vehicle.
Noob?
Also at the pad, we've added additional fuel tanks, enabling the ability to supply liquid methane to the booster stage. We've also updated the acoustic water suppression system to protect the pad during engine firing. Vulcan was designed to be similar in height to the Atlas vehicle, to enable many of the key interfaces between the vehicle and launch infrastructure to remain unchanged.
It's pressure stabilized poison because if it's not pressurized, it'll literally crumple like an empty soda can. Centaur can't stand up by itself unless it's pressurized. True story. So if they fire this and the bracket's holding it down, they won't fail. They're engineered to hold down a rocket that makes like 6 times the thrust of this thing because, Zombie, you want to be absolutely sure that what you're saying, like them testing it and then letting it go, they want to be absolutely sure that that doesn't happen. They should be coming out of the hold to Rivian very quick. What's up, dude? How you doing? They are in a planned hold. They're preparing for the go, no-go poll right now. Similar height to Atlas, so you could crew rate Vulcan too. Maybe. Or does the crew access arm at Slick 41 Blinga have a white room that can slide up and down for different vehicles? It's the latter. It can do that. Yeah, the crew access arm actually has a jig piece on the front where it can move up and down. It's not for Starliner. It's for Starliner Atlas, but it's for Dream Chaser and Vulcan. True story. For late loading stuff into Dream Chaser when that need arises in the future. What's underneath the Delta IV Heavy's fairing? Payload. Starship pressure stabilized as well? No, MCD. Pressure stabilization can make the rocket stronger, but Starship can stand up by itself. It can stand up on its own. They're built vertically, so they can, yeah, they can stand up by themselves. Now, crew rating in new launch vehicles, is that a simple process or harder? It's harder to do it after the vehicle's been designed. It's easier to do it while you're designing said vehicle. Pretori, preparing the pull for resumption of count. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. By the way, is it true that the F-35 project's facing unexpected maintenance costs? I found this on Quora recently. No idea, Hooded. When will then be now? Soon. Check your thirst at the door, Aqualux, damn it. Check your thirst at the door. Y'all are sick. You can see pad 40 over there on the left. It's actually really cool. Really great shot. Yeah, AOD, I know what you mean. I lived in Winter Park for a little while, a long time ago at this point. But yeah, Florida's a good time, man. It has rockets and race cars, two things I'm very fond of. Might not have everything for you all, but some of you, like you, but not that guy over there. No, that guy's like, I hate Florida. Yeah,
This is Vulcan Mission Control at
cool.
T-minus 7 minutes in holding. In a few minutes,
lightning
launch
tower
conductor
zombie.
Dylan Rice will pull the team for the final go to pick up the count.
You don't need lightning hitting
While
that.
we wait,
It'd probably
let's
be a
learn
bad
about
thing.
today's flight readiness firing from ULA's president and CEO, Tori Bruno.
TB!
This is such an exciting day and one that we have worked so hard to reach. The first Vulcan flight rocket is on the launch pad. Flight readiness firing, or FRF as we like to call it, is a full vehicle tanking and engine hot fire for several seconds. The FRF includes tanking of the Vulcan booster and Centaur 5 tanks to assess pre-launch procedures, including a terminal count demonstration starting at T-minus 7 minutes and culminating in a short duration engine firing. Test takes place at Space Launch Complex 41 at Cape Canaveral, the only currently operational launch pad capable of launching two different rockets. Objectives for the PTT and FRF include systemic validation and testing of flight-configured launch vehicle and its associated ground support equipment, including demonstration of day-of-launch integrated closed-loop control of vehicle systems and the BE-4 engines.
I'll explain this stuff in a second if this
Confirmation
doesn't
of
make sense.
operational readiness of vehicle airborne and GSE systems, facilities, as well as ground and flight software. So truly an end-to-end preparation and practice for that big launch. Demonstration of successful vehicle command engine start sequence and shutdown is also part of this, as well as validation of operational timelines and sequences. The test approach for PTT number 2/FRF allows us to buy down risk as we demonstrate the system in a measured manner. Such an exciting day. Go Vulcan, go Centaur, go FRF.
That guy shows up to Sabaton concerts for fun. I'm serious. He showed up at a Sabaton concert and got backstage. Now, you can be cool, but you're never going to be Tori Bruno cool, okay? Who's Sabaton? What?
Engineers and managers are polled for system status and readiness to proceed. This is the final status check for all Vulcan vehicle systems, ground systems, and the U.S. Space Force Eastern Range.
They're an awesome
The vehicle
metal
system
band
readiness
that
poll
has-
includes
that writes
electrical
songs about
systems,
history.
hydraulics, pneumatics, propulsion systems.
So Nova, Sabaton is in the Hearts of Iron as DLC for music that you can listen to, because they write about their metal songs are about battle. It's freaking historical battles too. It's really, really cool.
All steps complete prior to the status
All
check.
right, here we go. Yeah, Demon, I don't want to talk about that. Okay. The Beastie Boys. I don't know what that has to do with Sabaton, but yeah, the Beastie Boys are good.
LC
too.
switch is ready.
Yep, this is a live poll, dudes. Let's do this.
Status check to proceed with terminal count, Vulcan systems.
Here we
propulsion. Go. Hydraulics. Go. Pneumatics.
Go. Go.
LNG. LO2. LO2.
Go.
Water.
Go.
Centaur systems. Propulsion. Go. Pneumatics. Go. LO2.
Chat.
Go. LH2.
Go.
Hazgas.
Go. Hazardous
Electrical
gases.
systems. Airborne. Go. Ground. Go. Facility. Go. RFFDS.
Flight
Go.
termination
Flight
system.
control. Go. CC cube. Go. Operation support.
Go.
COM. Go. Umbilicals.
Go.
ECS.
Go.
Redline monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready for FRF.
Here we go.
Mission director.
You have permission to execute FRF.
Proceeding with the count. ALC. Verify T0 is set for 0105 Zulu. Verified.
Polling is complete. The ULA
8
team
minutes.
is go for today's flight readiness firing. A few minutes before firing, you'll be listening to Dylan Rice and his team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes, including verifying fuel tank and pressure levels in both the Vulcan booster and the Centaur upper stage. Within the final 15 seconds, you'll hear Go FRF. This is the final status check of the Vulcan and Centaur readiness. At T-minus 7 seconds, the ROFIs, or radial outward firing igniters, ignite. At T-minus 5 seconds, start command is sent to the engines. At T-minus 3 seconds, the main engines ignite to demonstrate BE-4
Lots of
operation
water,
in the
Steven.
integrated vehicle
You'll
system.
see. Lots of water.
At T0, the BE-4 engines will throttle down, mimicking the nominal shutdown that typically occurs at booster engine shutdown, or BECO.
Should be releasing the hold here momentarily. See this right here?
Before we
Steven?
continue, let's check in on the weather this evening.
Nitrogen, water. They spray
Ground
the
winds
nitrogen
are 5
into that
knots
tank,
out of the south,
and the
the
water
temperature
shoots
is
out a bunch of
77
nozzles and
degrees
absorbs all the heat.
Fahrenheit. There are no concerns for rules.
Yeah, you don't need to worry about the wind when it's not launching.
This is Vulcan Mission Control
so,
at
Blinger,
T-minus 7 minutes and
Yeah,
holding.
see this?
We
There's a
anticipate
gas
releasing the
purge
hold in
sound
just a few
suppressor.
moments.
I've stood right there, dude, which is really cool.
3, 2, 1, mark.
Count release. T-minus 7 minutes.
655. Ground pyros enabled.
I'll do what I want, all systems. Yeah, Bill, I know. They showed it. They showed it on the NSF stream. Me and
The
me
countdown
and Das.
clock has resumed, and we are go for flight readiness firing at 9:05 p.m. Eastern.
It's
a
just
few
a
minutes
test fire,
from
Clayton.
T0, we'll raise the volume on our team so you can hear the final preps taking place.
Nice observation for the nitrogen in the water tank. Sendell did. It's Yeah, I've stood there. I've had the
This
guy
is the
that designed
first time the
this pad
team will
explain
fire
that
up
to me.
the Vulcan rocket's BE-4 engines
Sorry.
at Space Launch
But
Complex
yeah,
41.
no, I wish I could say
Let's
I'm not
learn
good.
more
I'm not
about
that
this innovative rocket.
ULA's new Vulcan rocket is designed in Centennial, Colorado, and built in ULA's 1.6 million square foot production facility in Decatur, Alabama. At the base of the rocket is the Vulcan booster, comprised of 2 aluminum propellant tanks and powered by dual BE-4 engines.
What's on the cardboard for Fred when you work on the truck tonight? License plate illuminators on the back. Flykin is the big one, and then there's a bunch of other small things. Interview. What exactly do they learn from this test? This is an fully integrated test, dude. You're not brain dead. It's a fully integrated test to make sure that all systems work correctly. So, doing a fully integrated test like this is probably a good idea to make sure, for instance, that the computers on the rocket control the engines correctly. You want to make sure they're doing that before you let the thing go off the pad, and this is their way of doing it. This is their way of testing for that. Think basically just doing as much as you can to make sure the countdown sequence works, the auto sequencer works correctly. Countdown sequencer and auto sequencer are kind of the same thing. I guess that the simplest way to say it would be make sure all of, well, what's a better way to say it? Okay, I got it. So, long story short, when a rocket counts down, there's a lot of different things happening, even though we just see the rocket sitting there. There's a lot of things happening. Propellant is getting loaded until the last second, then propellant gets purged out. There's vents that are going. The sound suppressor gets primed, and the onboard computers are controlling all this stuff, with the exception of the sound suppressor. That's a different system. What they're trying to do is basically make sure that the computers and the software on the vehicle can control the vehicle and control the vehicle in the way that they want. That's what it is. Basically, make sure the software is configured right. And the best way to make sure that the software is configured right, the guidance system, which is the most important part on that rocket, the best way to make sure that that's configured right is to put it out on the stand and make sure that it can command a start sequence, amongst other things. That's the best way to do it. Like Tori Bruno said in that video just a second ago, it's an integrated closed loop system, meaning that the computers have primary control of all the vehicle functions. They got to make sure that it can do that. You don't want to go launch it and then have the computer not work with like engine throttle down or something. That's kind of important. Or shutting off the engine. You don't want to fire a rocket engine till the tanks are empty. It explodes. It won't like that. For instance.
This vehicle configuration is unique to the FRF test.
The more you speak, the
with
more my
no
comment. Ooh,
spacecraft,
I'm sorry, I didn't
payload
hear
fairing,
that.
Or SRBs.
Where'd your comment go?
After a successful FRF, the vehicle will be inspected and reconfigured into the flight article.
The guy said great explanation.
It will then follow our standard processing operations, and the encapsulated spacecraft and SRBs will be mated before launch.
Yeah, dude, it's just making sure that the software works correctly. But the best way to do that, have the software control the hardware. Do everything but send it. XPC, you made it for the rockets,
2 minutes, 30 seconds.
Here we go. Hey, Moose, what's going on?
You may also notice that the Vulcan logo is covered in a layer of ice on both the booster, LOX, and methane tanks. These aluminum tanks are uninsulated, so condensation freezes when the tanks are filled with cryogenic propellants. The portions of the vehicle without ice are composite structures or are covered in SOFI, spray-on foam insulation.
Orange rocket good.
Vehicle internal. Slot sequencer start.
So watch.
1 minute, 50 seconds.
Interview. You'll see these flare stacks purge out all the remaining fuel out of the lines. They should get big here in a second.
1 minute, 40 seconds.
That one's already big.
Launch enabled. 1 minute, 35 seconds. FTS armed.
T-minus 90 seconds. The rocket, ground systems, and eastern range are go.
1 minute, 20 seconds.
It's full. It's an all-up test, Raditz.
SCS count started.
They're tanking the rocket in the exact same way that they would if they were going to launch. But obviously they're not. It's missing a piece up top. The flight termination system is there to mimic real-life launch conditions.
60 seconds.
This core will
We're
fly
about
in the
1
future,
minute
Electron.
away.
In a few moments here, we'll hear the range operations coordinator report the range status. And then...
Vulcan tank at step 3.
Oh. "30 seconds. What is that white smoke? It's gaseous oxygen. Up there, this is condensation because the propellants are super freaking cold. There was no...
16.
Okay.
Ground vent valves secured.
Go, FRF.
T-minus 10, 9, 8, 7, 6, 5,
Methane purging system
4,
ignited.
3, 2. We have ignition.
And off. That was baller. Did you see that? That was awesome. You saw the thrust vector controller's working. That was so cool. Okay, you shut the firing igniters off. Okay, you can shut the...
LC switch not ready.
Ready to reset the clock at T-minus 7.
That was a lot of sparkling.
We just saw ULA's Vulcan engines throttle up for the first time.
No, that worked. That's what it was supposed to do. I didn't get the timing exactly right, but... No, not full duration. The pad can't take a full duration burn, man. It's not a test stand. It's a launch pad. Launch pads are only designed to be able to corral the thrust of a rocket engine for maybe a couple seconds, like that long.
LC, this is Peony 1.
Go, Peony 1.
Vulcan tank pressures are stable.
Rice announced
Nice.
ignition, power, and shutdown
Very
of
good.
Vulcan's twin BE-4 engines.
Very good.
The team is now looking at how the engine operated, analyzing data from the firing, and safing the vehicle as we prepare to detank.
Go ahead.
I'm looking for a status at step 40.
I agree. The long
Back to chill
Rofi,
mode.
Roger.
long Rofi ignition was just to make sure that all propellants were purged out.
And LC, this flight control.
It was, Shaw. That was it.
60 SBAPs. SS.
Yep. Flight readiness firing is only
Once
for
we
a
start
second, dudes.
detanking and the booster tanks start to warm up, the Vulcan logo will reveal itself again.
Are the 3 nozzles for engine purging? They're for LOX, gaseous oxygen purging. And is the BE-4 an in-house? Blue Origin
The
makes
rocket
it
you see
like
at Slick 41 today is the same vehicle that will be launching the first certification flight. Let's learn more about how it's built.
Yes, let's. So that test
Vulcan
looked good.
Centaur
All right,
production.
All right, we've seen this already. All this time for that? Okay. Cloud, yeah. Yeah, man. If you're not familiar with like space flight, that was like not that good of a payout, right? But if you know a little bit about like rocket engineering, that was actually a huge deal. that was a really big deal. If you're like rocket nerds will know. No. Yeah, it's not that much of a payout, but that's space flight in a nutshell, dude. Lot of downtime for very little bit of uptime. It takes years to make a rocket, man. It takes years. It takes years to fabricate it, to manufacture the whole thing. Thousands and thousands and thousands of man hours. And the whole thing's done in 8 minutes. Even if they launch, it's done in 8 minutes. Yep. But the payout, though, that was pretty good, right? A lot of fire, man. Fire! Fire! Can the rofies be turned off? Figured they'd be like an SRB, just run till out. I'm not sure, Mutter. I don't know how those firing igniters work. Let's put a payload on it and send it. They will after they get the data. Yeah, they have to... Now what they have to do is that thing offloaded at probably a couple... I'd say a couple terabytes of data right there, easily. Yeah, just from the whole sequencing down to the ignition. Yeah, it's probably a couple terabytes worth of telemetry and data. Now they got to go look through all that to make sure that it's right. And then they'll put a payload on it and send it. Did I miss it? Yep. I haven't done a couple research. Yeah, like the mystery goo. It needs mystery goo. It's not Kerbal enough. It needs more mystery goo and more boosters and more struts. Can we replay the nozzle moving? Oh, absolutely, dude. Yeah, you want to see it again? I want to see it again. Nope. Here, let's see it one more time. 6, 5, 4, 3, 2. We have ignition. Nice. Watch, you can see the right nozzle moving. Oh, the engines went like this and they went back. That's sick. That's really freaking cool, man. I want to see it again. We have T-minus 10. You can just barely see it from the camera that's on the other side. The nozzles actually go that way first, and then they go back the other way. Watch. Oh, that's so cool. Man. You know how strong the hydraulics need to be to do something like that? Those rockets put out 550,000 pounds of thrust. Okay, for metric people, that's like 2,500 kilonewtons. That's 550,000 pounds of thrust. Those hydraulics are pretty freaking strong, man. Looks like Tori said it was nominal. Excellent. Nope. Googling, I don't do that. Yeah, really, really cool. All right. All right, guys. Well, that was the flight readiness firing. That was, I know, didn't seem like a lot, but that's actually really cool. Trust me. There is a time in the not too distant future where Vulcan is going to be flying almost as much as Falcon 9 is. So, yeah, get ready. Get ready. Will the engines be disassembled and checked? Willie, it depends on if they see a funny in the data somewhere. If they don't see a funny in the data, I don't see any need to take the thing apart. Should work just fine. I want their sparklers for my 4th of July. Yeah, I know what you mean. What was all that swishing sound when the engines turned off? Gas purging systems? As much as Falcon 9, right.
What?
Primo's here. So much for your sleep schedule. Yeah, yep. Primo's here.
We'll work till midnight, then we'll go to bed. No later than other day. No later than any other day.
How's the air quality tonight? It's all right. Don't they have like 5 or 6 already built? Yep. Oh, dude, they're showing it again. Nice. Very nice. Very nice. That was great. All right, guys. that's gonna do it. Fellas, I'll be honest with you. I just want to bust this truck workout. Like, we don't need to. I just want to get it done. Okay, I'll give you guys an update to the work that we're gonna do on the truck. I'll give you an update tomorrow. Okay, I'll show you everything that we did. I just want to get it done. I'm tired. A little tired.
Oh, okay.
Hey, Yurovich. Want to see what Grab Shark's doing? He is streaming, but I decide who raids ultimately, dude. Very smoky in Syracuse. Yep. So I hope you guys enjoyed the FRF. I'll give you guys an update what's going on with the truck tomorrow. Let's go see what Italics is up to. My buddy Italics is playing. Oh, he's playing Stellaris. Oh. Let's go give him a good raid. Let's go give him a good raid and see what he's up to. Yeah, I hope you guys enjoyed the coverage. If you're newer to the stream, I cover most rocket launches here. If I'm not covering it here, I'm covering it for a space flight news outfit called NASA Spaceflight. But it'll always be here. So, thank you very much for watching. I do appreciate it. And for the people that watch for games and rockets, we'll be back with Stellaris tomorrow. All right. Thank you very much for watching. We got to come up with a Stellaris-style raid for Italics. We should say, the Eric Johnson Continuum is raiding your stream. Yeah. We are your rival. No, don't say that. The Eric Johnson Continuum, the EJ Continuum, is raiding your stream. So go see what my buddy Etel's up to. He's a good streamer. I swear, great dude. Excellent streamer. He's playing Stellaris, a game that I just started playing. So, yeah, go see what he's up to. And I'll talk to you guys tomorrow. Thank you very much for watching. Minute Chicken. Have a good night. I'll see you later. Thank you.